Hi, Chair Brawley and Commissioners. Andrea Kells with McGuire Woods for Dominion. With me here today is my colleague Nick D'Antonio, also with McGuire Woods. And on the Dominion panel, we have starting at the far end, Nathaniel Rice, Supervisor for Electric Transmission Strategic Initiatives, Scott Gaskell, Vice President of Regulatory Affairs, and Stan Blackwell, Director of the Data Center Practice for Dominion. Thank you.
Good morning, and you all may proceed.
So good morning. Thank you, Chair Brawley and Commissioners, for the opportunity to speak on these incredibly important topics. Again, I'm Scott Gaskell, Vice President of Regulatory Affairs for Dominion Energy. And so as this commission is well aware, and has been noted by several speakers yesterday, so Virginia is home to the largest data center market in the world. So our filed comments and our presentation today are largely Virginia focused. But because, of course, that's where we had the most experience dealing with large load and data centers in particular. And we offer it in the spirit of sharing best practices and, quite frankly, lessons learned over the years. So as a utility, so we've been serving the growing data center industry for well over a decade. And we have experienced in, the incredible increase in the pace, the scale, and the size of these projects that are interconnecting to our system, and of course that we have an obligation to serve. So to put this in context, approximately 25% of our sales today from the utility are from data centers, and that's expected to grow to approximately 50% by 2035. So significant portion of our sales and our load is served to data centers.
And Mr. Gaskell, can you pull the microphone a little closer
yes.
to you? I think some people in the back of the room can't hear you.
Yes, apologize for that. Thank you. So Mr. Blackwell is going to talk about our load forecasting process, particularly for large loads, how we know what is real, what is speculative load, and how that process has evolved over time. He's also going to talk about our contracting process for these large loads and how we do have a robust contracting process as we bring these customers to interconnection and serve them. I will talk about some of the tariff provisions that we have proposed in Virginia in an open proceeding in our recent rate case, and including how we're looking at certainly continued fair allocation of cost that we are incurring for the data centers and for all the large load customers, as well as looking at mitigating potential risk of stranded costs in the future. And then Mr. Rice will talk about the load transfer event that we have experienced, as well as what the CERC witness discussed yesterday. So with that, I will turn it over to Mr. Blackwell.
Good morning. Can you hear me? So I'm fortunate to lead Dominion's data center practice. Just as background, I've been working with the industry for over 13 years. We had to create a data center practice given the volume of work. So what we did is took the economic development function for data centers out of our corporate center. Most utilities do that in a centralized group. So that falls under my team. We took the key account function, the care and feeding of connected customers out of the other groups and moved them into our group. And we also took the forecasting for data centers out of the corporate function, and we forecast that separately in the team. So we're kind of wholly contained, dedicated to data center customers. And over the years, we slowly migrated to that model, and that's kind of where we are today. So there were a lot of questions that you asked, and hopefully I can cover a couple of those as I present today. I'll start with the largest data center market in the world. There's 2 or 3 independent organizations that rate this. What I'll tell you is today, if you look at JLL, happens to be one that we look, they do a nice report. And if you add up the next 5 largest U.S. markets, add them together, they're not as big as our Virginia market. In fact, it's actually Loudoun County. It's about 30 square miles is the largest market in the world that everybody else is compared to. However, like I'm sure just like Duke is saying, you have, the industry's kind of growing up maybe in Raleigh and Charlotte, but it's slowly expanding out. And we're certainly seeing that in Virginia as well. As with any industry, you tend to have a small number of very large players and then a lot of smaller players. That's true of our market. Just as the slide says, if you take our top 7 customers, that's over 72% of the market. And so our forecasting process, we actually forecast by customer, not by contract. We focus on our 7 largest and fastest growing customers, and then we put everybody else in an 8 segment and forecast that separately. And I'll come back to that. But you're basically, that's one of the key elements, not the only one, that we use to eliminate speculative contracts or demand in our process. To give you a perspective, so I've been working with this industry since 2013, and back in 2013, our data center only demand was about 462 megawatts. And we peaked this year at 4,200 or 4,200 megawatts. So that's about, on a compound annual growth rate, a little over 20% a year. And we're adding load every year, 500 to 600 megawatts of actual metered load just for data centers, to give you an idea of the kind of growth we're experiencing. And I think Duke will see as well in other areas of the country. I'll get back into this, but data centers use a lot of energy. There were a lot of questions about curtailable load. The industry in Virginia today is not a curtailable market. It has to do with the nature of how the data centers run there. And so our load factor, which is how they consume megawatt hours relative to their demand, if you're at 100%, if your load factor is at 100%, that means every hour of the day you're consuming energy, relative to your demand. So in our case, the load factor is about 90%. That's industry-wide. The point of that is the industry, a very simple analogy, is like a chainsaw. You never start a chainsaw and let it idle. It's either running wide open or it's not. That's the way data centers run on a utility system. They run wide open, at least in our service territory. And that kind of growth, just that short perspective, is why we went to a data center practice. Like most states, the data center industry grew up in clusters, typically in major metropolitan areas, and you're starting to see them spread out. There's kind of a couple reasons for that. One is there tends to be more capacity in more rural areas. And second, you're starting to see the development of artificial intelligence training data centers where they can train load, and they tend not to put those, at least in our experience, in major markets. So in AI, there's kind of 2 modes of it, if you will. One is you train a model. So you cycle, your data center cycles up and down to train a model. Once it's trained, you take it out of that, you put it in what's called an inference data center. And that's the one that runs like a chainsaw. So once you have a model trained, it runs all the time. You don't tend to want to curtail that because that's what customers access. But the training you can schedule or you can change. Now, the reason that's important is if you have training data centers, you're still going to have the demand that you would expect, but they're going to consume less megawatt hours because they cycle up and down. I just share that because it's our opinion, at least in our service territory. We don't have any training data centers today in our market. We think we have some being connected, and they tend to be located in rural areas. The main driver, that's economics. You're not going to spend $4 to $5 million an acre to put a data center in and then not run it 100% all the time or 90% all the time. I mean, it's sheer economics. Last thing I'll tell you is we're seeing, and I think every utility in the U.S. is saying, there is a massive influx of capacity requests. There are new companies coming into the market that are inflating some of those capacity request queues. To put it in perspective, we have 64 gigawatts in our queue. That's not all going to be connected. Our 20-year forecast for data center demand is about 20 gigawatts. So we know the capacity requests are much higher than where we're expecting our demand to be in 20 years. There's a lot of new firms entering the market. We have 54 discrete data center customers on the meter today, with covering about 450-ish meter points, or accounts, if you will. But we probably have another 50 developers that are trying to get into the business, whether real estate firms or people that say, there's a lot of money to be made. I'm going to now be a data center developer. And so that those new market entrants are increasing the request for capacity. We're not convinced that that's going to increase actual data center demand. It's just competition, everybody competing for a growing slice of the pie. We have seen a significant increase in the size of capacity requests. So our typical build today is a 300 megawatt campus. On that campus, you'll see anything from 3 to 4 buildings. And today, a big building, about the biggest we're speccing out, is a 100 megawatt building. To put that in perspective, think of the biggest Walmart you've ever seen, 3 stories tall. Now, most data centers are 2 stories. They're only 2 floors, but they have very high ceilings because they have to move air to cool. So just a rough way to think of it is the largest Walmart you've ever seen that's 3 stories tall is a typical data center build we have. That's about a 100 megawatt building. You hear these really, really high values, 500 megawatt campuses, 1 gigawatt campuses, 2.4 gigawatt campuses. We've gotten a 7 gigawatt load letter. The point is you're not, most customers don't meter at that size. They cut their, they kind of meter by building has been our experience. And so roughly you'll have, on the new build, about 100 megawatt sized account, and you may have 3 of those on a particular campus. It's kind of the way that's happening. If you look back in 2013, the average data center was 10 to 20 megawatts of building, and it's speccing out at 100 megawatts today, just to give you an idea of the growth and electrical density. We've been forecasting for quite a long while. I've been leading the forecasting team for data centers since 2013, and so we've had a lot of learnings over that time. And our forecast is now stable. We actually don't forecast by contract. When you tend to do that, you get an ever rising forecast. And my point is every year we do our forecast and we're just tuning it. It fluctuates a little bit in individual years, but it's stable over time. If you go to page 4 of the presentation, there's a lot of questions. You read a lot of material that data center growth isn't real. The point of this slide is pick a metric and everything's growing. Just everything about the industry is growing. And I think that's the point of the slide. And this just shows you the net change from 2013 to 2025 as of today. I will note the growth in demand is over 800% over this time period. If you go to page 5, so we're in the PJM market. And this chart is for the DOM zone. So the DOM zone is our transmission service territory, which is much larger than our retail service territory. In the DOM zone, we serve a lot of the rural co-ops, I think just like Duke does in North Carolina. In fact, we're the largest transmission provider in the state of Virginia. So this forecast here is the DOM zone. It includes Dominion's retail service territory data center forecast, as well as that of the co-ops. And you can see over time that the growth in the aggregate data center, or this happens to be all in growth, but you can see it's been climbing over time, and that is all due to data centers. And the main changes in here are you're seeing the expansion of data centers into the rural co-op service territories. Our forecast has been relatively stable over this time period, but most of the growth has shown up in the co-op service territories. I'll come back to the theme, is data center growth real? If you look at that bottom bullet, this year we hit 10 all-time peaks. We did, I think it was 3 in the winter. And what data centers do for system peaks with your system is they're kind of a baseline. In our market, they run all the time. So it's an ever rising baseline, and your residential customers drive your winter peaks. When it's really cold, that's when you see the real spikes in the winter. Data centers actually don't peak in the winter. They're very steady. Some of them can open up I call them baffles or windows, let ambient air in when it's really cold. So they don't tend to spike in the winter. They do peak in the summer, and so the highest demand occurs typically in July or August when it's the hottest. And so their demand curve over time kind of peaks in July or August then. And so they're driving your summer peak typically. The residential customers are driving your winter peak over time. But the point is the demand's real. It continues to grow. And again, we hit 10 all-time peaks just this current year. We're probably done setting all-time peaks until January 26, I'm guessing. So we'll see what the weather brings. I will go to the next slide's about contract structure. And this, we started doing this. We have evolved over time into a 3-contract structure. So I'll give you a little background on this. It used to be probably, it used to be till about 2015, we had one contract. So we would build infrastructure for a customer. And at meter set, we would ask you to sign electric service agreement, which then referenced your terms and conditions, the tariff. And we didn't have a contract prior to that. It was all when I set a meter, you sign a contract. We had to move away from that due to volume. So we have an obligation to serve, and we have, like I said, 64 gigawatts of requests to look at capacity. I'll break that down here in a minute. But so we had at any one time 30 to 40 gigawatts of requests to be engineered. We have an obligation to serve. So if you hand us a request, we have to engineer it. Well, you're building transmission, substation, and distribution wires. And that takes a while to engineer. You have to go to your distribution planning group. You have to go to your transmission planning group to build the solution. So we went to an engineering letter of authorization that says, if you're serious, you sign this contract, you give us $250,000 deposit, and we will engineer your project. We went to the deposit because we were engineering so many projects, and those that don't proceed, there's no cost recovery. And I think one of the issues, one of the questions is, how are you making sure they're paying their fair share? We do that with engineering. If I engineer Commissioner Tucker's project and he decides not to proceed, we'll take that deposit, net the expenses we had for engineering against that, and refund any monies we didn't spend. So we know now that he's paying for his cost of engineering in that example. At the end of that 9 to 12-month engineering period, we then take the results and say, Commissioner Tucker, would you like to proceed to construction? We use that method, and once there's no obligation in the engineering phase. We have an obligation to deliver results, and then you have to decide, do I proceed? When we sign a construction contract, there's 2 obligations in that in my example, Commissioner Tucker. The first one is, I'm going to start putting money in the ground to connect your site to existing transmission, and I'm going to build a substation, because virtually all of them require a substation. And just say that cost tends to run between 25 million to, say, 300 million, somewhere in that range. It depends on how much transmission you have to build. And so in that construction contract, we say, if you back out and we put 200 million in the ground and then you cancel your project, you're responsible to reimburse us for that invested money. So that's obligation number 1 in the construction contract. Obligation number 2 is, once we build this and energize it, you're required to sign an electric service agreement at the amount of the installed capacity that you asked for. We went to those 2 requirements. We really haven't had a lot of canceled projects, but we would build infrastructure, and then the customer would come back and say, well, I asked you to build 300, I only want 100. And so we put that requirement in there to say, you asked me to build it, you're now responsible. The point of those obligations is now that customer has to make a financial business decision. I've got significant obligations here. Do I want to proceed to construction? We also put a 90-day clock on this and said, you have 90 days to make a decision whether you want to proceed to construction. We did that because we would render engineering results and then the customer will go out and shop for their end user. And that could be a couple of years. And we've got a project sitting in our queue that it's just clogging the pipes for like, a very simple way to think about it. And so we put a 90-day clock in there, and that's the quickest way to eliminate speculative projects. You're not going to sign up for those obligations if you have, if you got to take a real risk unless you got an end user. And we do see some customers doing that, but at that point, we've got them held accountable. Once we build under a construction contract, the electric service agreement is the final contract, and that's really the one that governs how we provide service, utility service to them. We happen to offer that contract 1 year in advance of meter set. It helps the data center customers, helps get their end users comfortable, lends them some comfort that they're going to get service. And so we happen to offer that 1 year in advance. We went through about two, 3 months where the customers were asking us to give them 4 and 5 years in advance. We did that for 2 months and immediately stopped. We were papering away system capacity that we knew wasn't going to be used. And so, we went to, you get them 1 year in advance. That's the only time we're going to offer them. And so my point about giving you that history is we've arrived here over time trying to address issues that have come up in the process. I'll end by saying, I've heard some questions, and well, I'll obviously get into this, but, a contracting structure alone is not the only answer. There's no silver bullet for the kind of growth this industry is bringing. You need a variety of tools, tariffs, contract structures, changes to your terms and conditions, policies. You need the whole basket to help manage this kind of growth. It's great growth, but we all have the same, objectives in trying to serve it. So thank you. Oh, sorry, got one more slide. This last slide is, I mentioned we do not forecast by contract. We used to do that. We tended to find you have to make so many assumptions. Most utilities start that. The majority of utilities are doing that. We've been at this for a very long time. We have over about 12 years worth of meter data by month for every account. And so we moved away from forecasting by contract. But let me explain what this is. So we forecast statistically our data center load. It is not an econometric model. I think there was a presentation yesterday. GDP is not a variable in here. That was kind of the comment. We do it statistically by our largest customers and look at their past behavior and then make an assessment whether that will continue in the future. And we haven't seen a change in the behavior over the whole time period, 2013 to today. So we forecast our data center load. This is just data centers in our retail service territory. And then we look at what do we have connected to the meter in terms of electric service agreements. And that's the blue bar. And this is as of a point in time. So you'll see the blue bar will grow a little bit and then it gets flat because as of the end of July of 25, that's all we had signed at that point in time. So it's flat out into the future. And the point is we have about 9.8 gigawatts on the meter of capacity contracts. Our metered load is 4.2. And so in our experience, your metered load relative to capacity is anywhere in the 40 to 50% range. That's just kind of over our experience. It's a little lower now. It's in the 40% range because we just signed a bunch of new electric service agreements that they're growing into, but just a rough eyeball somewhere around 50% relative to your capacity contracts. That's kind of what we've seen. That's firm. They're going to grow into that, the blue bar. So that's your immediate growth validation. The green bar on here is construction contracts. Now, remember the two obligations, fairly hefty obligations. And so we're building as of July, 7.1 gigawatts is what we have under construction capacity under construction. But remember, I've got these two hefty obligations. So once you start putting iron in the ground, we've never had anybody cancel. Now they'll cancel before we start the construction, but I think we've had 2 of those. over the whole period we've been doing this. So once you get to construction, the customer's firm. And so the point of this is we're laying our forecast against connected, the blue bar, connected contracts, the green bar, what's under construction. And the point is we have contract coverage today for our forecast through 2046. Okay, that's the simple way to think about how you compare our forecast to contracts. The yellow box up the top is as that point in time, we had 30 gigawatts worth of contracts in the engineering phase. So those were engineering, and we don't, we just show them for relative sake. But our focus is we want an accurate, conservative forecast that we can back up with contracts. And this is a simple way to look at it. What this doesn't include is another 18 gigawatts of load letters that aren't under contract. That people are saying, I got a project, and we don't sign a contract until you have site control, site plan, some other things before we'll engineer it. And so this is, hopefully this kind of wrapped up a lot of the concepts, but it's how we lay our forecast against our contracts to say, do we have a valid contract? Or excuse me, forecast. So thank you.
Great. So I will pivot a little bit to kind of taking on, go to contract, sign an ESA, and then that links them to the tariff and the tariff provision. So I want to talk a little bit about what we have proposed in our most recent rate case in Virginia in terms of a high load tariff dealing with cost allocation and the risk of stranded costs over time. So what we've got here in sort of the tools in the toolbox, if you will, that you're seeing a lot of utilities across the country in dealing with the large load tariff. So and really ultimately what the utilities and the commissions, I think, are trying to wrestle with is this balance between customer flexibility with the large load, the economic development interests. We generally want, it can be helpful to all other customers in putting downward pressure on rates. So how do we provide that flexibility to these customers to do business as they need to do, but also protecting other customers both in the near term and over time. So it's that balance that we're trying to grapple with. And so you're seeing a lot of these similar tariffs looking at discrete customer classes where you're breaking out the large load tariff and large load rates in a separate class. You're seeing things like minimum demand charges or take or pay contracts.
Can you pull the microphone
I'm
closer
so
to you
sorry.
again?
I'm so sorry. Yep. So minimum demand charges, take or pay type constructs to ensure that these large load customers are going to be paying for the infrastructure costs and the investments that are being made on their behalf. And Commissioner Camera, you asked, I think, a couple of witnesses yesterday about sort of, is there a utility out there or approved tariff out there that maybe would be the model to look for. And I would just offer maybe a little bit of caution on that in the sense that every utility in every jurisdiction is going to be a little bit different, right? So we're all seeing these similar tools that we're using. But if a lot of people point to AEP Ohio, well, keep in mind they're a deregulated wires only utility. So they're not dealing with generation in their tariff. There are certainly differences between utilities that may be within an RTO or not in an RTO in terms of how you plan transmission and generation, how you operate, and what's available from the market in that standpoint. So there really are key differences between utilities and jurisdictions. So I think what you've got to look at, that's not to say we can't look at those other utilities and those other approved high load tariffs, and we certainly would learn a lot from them. But they really need to be tailored to each individual utility or jurisdiction. So that's what I believe. I'll flip to this. So this is, again, what we have proposed in our most recent Virginia rate case. I will note at the outset, this is an open proceeding. This has not yet been approved. But I do want to talk a little bit about what we have proposed as a means to address some of these issues. So there's really, I think, when we talk about this, there's two, I'd say, related but distinct issues. And one is the fair allocation of costs. And this really gets to or each customer class paying their fair share of the system costs. And then the second but related issue is the mitigation of potential stranded costs over the future. Are we going to make capital investments to connect and serve these data centers, and ultimately, are they going to be there to pay for those investments over time? So I'll just start with the fair allocation of cost. So what our proposal did is create a new high load factor customer class, GS5. And so this would apply to customers that are 25 megawatts and above and with an expected load factor of 75%. And so what this allows us to do is it's not exclusively data centers. It is predominantly data centers, but not exclusively. But really, when we look at the high load factor component of that, these base load type customers, their cost causation is a little bit different, and their rate design can be a little different. So by breaking them up into a separate class, it gives us more transparency and more precision in terms of the allocated cost to that class and that group of customers, as well as more precision on the rate design. And so we are not proposing to change any of the sort of core cost allocation methodologies, the average and excess methodology. We use 12 CP for transmission. So we believe the tried and true allocation methodologies work, but by breaking this up, it does provide more transparency and precision to those customers. Pivoting to the right side, the cost allocations, as I say, they work. It is premised on the fact that as you allocate cost to these customers, that they're actually going to be using the load that they said they're going to use and paying revenue into the system. If we allocate the cost to those customers and ultimately they don't ramp up or they don't use, they're not paying revenue into the system. So that's what this right-hand side is trying to address. And so what we have proposed are minimum demand charges. So think of it as a take or pay construct. So what we have up to now, for the most part, our customers are billed on their actual meter demand. And what this does is say, okay, you've got a data center or any large load customers, they have requested, let's just say 100 megawatts of capacity. So as Stan said, we're going to build 100 megawatts of infrastructure, your substation, your transmission, and then they will sign an ESA for 100 megawatts of capacity. If, however, they don't ultimately use the 100 megawatts of capacity, let's say they only ramp up to 50. Well, under our current tariff, their demand charges would only be based on the 50 megawatts of metered usage. So what this does is say, look, you asked for 100, we've built 100 worth of infrastructure. You're going to pay the greater of either your metered usage or 85% of your contracted capacity. So it puts a minimum financial commitment on them over time. So for transmission and distribution, we set that at 85%. For generation, 60%. The reason generation is a little lower, it is less site specific. We can use generation, if a data center in location A, maybe not using their full 100 megawatts, that generation can still be redeployed to others. Substation, not as much so. It's more site specific. It's less fungible, if you will. So we think it's appropriate to set the generation slightly lower than the TRD minimum. Importantly, too, not just the minimums, but we are requiring going forward a 14-year contract. Essentially what that is a 4-year ramp period plus a 10-year contract over time. And that is backed by exit fees and collateral. So if they were to terminate service prior to the end of that contract, they would be responsible for the remaining minimum demand charges over the life of that contract. So by doing this, we're providing a firm commitment from these customers that the infrastructure we're building for them and their fair allocation of cost of the system costs that they will be paying over time. So that's the intent of this. And again, it's pending before the Virginia Commission. So we will see what they have to say about it in a few weeks. And then finally, let me just back up one more thing there on the left. We have, and Mr. Blackwell talked a little bit about the load flexibility. We don't see that a lot in our territory currently, but we are committed to exploring it. And we are going to come back and propose some flexible load options for consideration if that can evolve in the future. We are very interested if that can be of value in the future. And then I will be brief on this slide. I'm mindful of the time. Really, this is just to show, illustrate that the current cost allocation methodologies, they generally do work yes, there are significant capital investments being made to serve these customers, but what you've got is very high load factor customers. So the sales being provided and thus the revenue being provided from these customers drive down. So you'll see like the North Carolina jurisdictional has been dropping as the load growth occurs in Virginia. And if I were to do a similar slide and break out the Virginia jurisdiction into residential, GS1, 2, 3, 4, 5, you would actually see that growth happening in the GS4 and GS5 classes, the large industrial commercial classes, and you would see the residential percentage dropping over time. So what the effect of that is the classes or the jurisdictions that are dropping begin paying less and less cost of the system to serve. So I will move on to load transfer. Thank you.
Good morning. I am Nathan Rice, as previously introduced, the Supervisor of Strategic Initiatives. And I'm going to kind of complement and continue on with some of the discussion that Mr. Martin from CERC had yesterday on the load transfer events. Dominion Energy has seen 2 load transfer events of 15 and 1800 megawatts respectively. The first one was July 10th of 2024 and then February 17th of this year. Both events, almost the same thing happened. Our lines detected a fault, the first one being a faulted lightning arrestor during a storm. The second one was a tree in a very narrow right-of-way, taking out 2 lines of or 2 phases of one of the lines. In both of the events, every piece of equipment that Dominion had operated as engineered and as designed. We went through our reclosing cycle, which is just a protective scheme. Most of the faults on the system are momentary in nature. Tree will fall near a line, it'll arc across, and then the tree will continue to fall to the ground. We can re-energize the line safely. In these events, they were permanent faults, so it went through its reclosing cycle, and at the end of it, the line had to remain de-energized. But upon the third reclosing cycle, or the third voltage depression from reintroducing those faults, we had the 1500 and the 1800 megawatts of load transfer. Now, as a former transmission operator, it can be extremely hard to identify what exactly happened from the transmission perspective, because we're only looking at the transformers then going down to the load. But off of those transformers, there could be many different circuits. On each circuit, there could be multiple data centers. So we, through coordination with Dominion Energy Distribution, we have installed meters that were installed ahead of time on select data centers so that we could identify their load characteristics and their performance. And so once we were able to get that, we could get a much more granular and higher level detail view of how the data centers operated. And as you can see on the top right graph, each of those green, I guess, dips, that's the fault introduction and then the reclosing cycles going through. And then you'll see on the bottom right graph, that load did not fall off until that third reclosing cycle, which is we found to be very unique and very interesting. It turned out that it was customers that had protection settings that were incompatible with our reclosing. And our reclosing, we've been reclosing with those standards for a long time, and they're industry standard. We confirm through NATF with many other transmission operators that's how they also operate. But the data centers didn't understand that at the time when they established their settings. And because we hadn't had a big situation like this, it was a latent error that had not reared until this moment. So as we went through and looked at each customer, thankfully each owner operator operates the same way across all their data centers, at least from what we found. But we found that each operator or each owner had vastly different standards. So we worked through with the data centers to establish maybe universal ride-through recommendations that would work not only in the Dominion Energy system, but we also worked with a lot of other utilities through the Large Load Task Force and the NATF. We also gained greater understanding of other ride-through standards for the data centers, for the customers, to try to identify other problems and risks that had come up. And then the other thing is we're expanding that deployment of those high fidelity meters at the point of interconnection. So that way, instead of at 50, it's part of the new FIR requirements that will install it at all of them. So additionally to our new FIR requirements, these are Dominion Energy standards that we expect any new generation or load that are connecting to the system will meet prior to energization, but then continue to meet through their operation period. We added some new attachments with the October 1st revision. That's all, and this is all public, so other utilities are able to view this. And we looked at other utilities as we went and revised ours. However, we have ride-through recommendations in attachment 8, which basically took what occurred with these two events and ensured that new data centers will not have that vulnerability anymore. We also are getting more granular models, so that way we can do some what-if type scenario for type analysis for these scenarios to determine what the impact could be from these type of events. We also took the NERC large load questionnaire that came out last year and adapted that and included that into the FIR requirements. So going forward, we've continued to work with a lot of our data center partners to try to identify some of these latent risks and ensure that they're mitigated before they become problems. We've also coordinated with NERC, CERC, DCC, name a 3-letter, 4-letter agency. We've probably met with them or will continue to meet with them. But as an industry, not only on the utility side, but also on the data center side, we feel like we've worked together and collaboratively to come up with solutions to mitigate this type of problem. And we've also opened the lines of communication to ensure that we can meet these type of risks as we proceed in the future with increased data center load. I hope that helps with understanding what happened in these situations and what we're doing going forward. And now we're open to questions.
Thank you, all three of you, for your presentations. I have a number of questions. I'm going to try to move through them as quickly as possible, and I expect that the other commissioners will have questions as well. I'm going to start with what we were just talking about, a very specific technical question relating to the event within 2024 that FERC, that NERC discussed some reliability concerns with data centers. And you mentioned on slide 15 about you discuss revising the facility interconnection requirements and that there would be recommendations and requirements for ride-through settings or requirements. Are those, at this point, are they simply recommendations or have they been implemented as requirements?
So with the customers that had the load transfer events, we coordinated with them to establish standards or recommendations, requirements that, and I'll say requirements, that would ensure this would not happen again, but also would still protect their equipment because we don't want to have any, they need to protect their equipment. So those customers are going through and they're implementing those changes on their equipment now. And those are also new requirements in the FIR. So going forward, any data center will have to meet those standards. And then the customers that did have that vulnerability are changing theirs and should be done by Q1 2026.
Okay, so it will be imposed upon or required by all data centers going forward.
That's correct, yes.
Thank you. So my next questions are for whoever is best to answer the question, but my first question is very general. There is a perception that electricity costs are going to be significantly increasing due to development and growth of data centers, and that all customers' bills are going to be significantly increasing because of data centers. And it's not going to be just the electricity costs for data centers, but all customers, including residential customers. Can you provide your perspective about whether that is an accurate perception? Because I think it is very widespread and we hear it a lot. And so is that accurate? Are there, you talked a lot about how with cost allocation and the different measures that you have in place that Dominion is looking to protect existing customers or residential customers, but can they be fully protected?
Sure. Yeah, great question. So I think, let me break this up into maybe two parts. So I think there is the cost to serve these additional customers. That's the additional transmission, distribution, generation to serve these. So that's certainly there are significant capital investments being made to serve these large customers. I think in that respect, our cost allocation methodologies generally work to properly allocate costs to different classes to different customers. And I think over time, from that element of it, if done properly, there could actually be downward pressure on rates because you've got these high load factor customers providing a lot of revenue into the system over time. I think the second element of it is the upward pressure that is being put on wholesale prices, both from an energy and capacity standpoint, being driven by the fact that the demand is outpacing the supply. And so we have seen certainly in PJM an upward pressure of PJM capacity prices over the last 2 years, and you're seeing that in energy prices as well. So the answer to that, so one, as a vertically integrated utility, we are less exposed to that because we do have the ability to self-generate and self-supply our capacity. So we're less exposed to that, but we are still short capacity and dependent on market purchases for at least a portion of that. So I think over the long term, addressing that and being able to self-supply over time, I think is very important. But a large portion of the increase that we're seeing in rates is really due to wholesale prices. Our fuel prices are going up, fuel costs are going up. So I think in terms of the infrastructure, I think the cost allocation methodologies generally work and will take care of it. But we've got this pressure from the wholesale market.
And I'll ask the same question for Duke's witnesses as a vertically integrated utility that is not in the PJM region that's subject to some of the issues that you mentioned. But is there also a gap, a period of time in which cost to all customers will be higher because of the infrastructure that is required to be constructed and developed before the data centers are at full capacity? Is that another element of cost to customers that is not easily able to be mitigated for existing customers?
That is a possibility, right? So as I say, there could be downward pressure on rates over the long term because the additional revenue from these customers will be on the system. There is a timing issue, right? That we're making investments in generation, transmission, and distribution, that those are system-wide costs. They go to rate base, but the customers haven't either connected yet or haven't fully ramped up to provide that revenue. So there is, I think you're absolutely right. There is a short-term gap there that perhaps we can look at through our cost allocation methodologies if there's a way to deal with that.
And then another just really general question, with Virginia being the largest market for data centers in the world, as you mentioned, very generally, what are some lessons learned, the most important lessons learned that Dominion has obtained, and what are some of the most important aspects that you think that this commission in North Carolina should be paying closest attention to?
Sure. You want to start?
Yeah, so I probably talk to a utility around the country about every week. And so my first piece of advice for them is there's a significant difference between the capacity requested and the meter demand for this industry. The nature of this industry, pretty much any industry, is let's build the capacity and grow into it. And so you don't want to forecast or assume your meter demand is equal to the sum of your capacity contracts. Again, I'll point back in the opening part of my presentation. You know, we're roughly 50% meter demand relative to contract capacity. And you know, it's been our experience that the demand curve is concave, shaped like a smile, and a capacity curve shaped like a frown. You know, it's convex. And that's never changed for us. Now, again, that's our market. But that shape has never changed. And so I strongly caution any utility, be careful about forecasting capacity. That's not what your system's going to look like. I think the second thing is a note of caution, all utilities, it's very logical to create your forecast by contract. It's very logical to do that because you have something in your hand. The difficulties in that, most people say, what's your load ramp? Is really one input everybody asks for. And that's relevant, but that tells you the timing. And what you really need to know is how long is it going to take for this data center to get at its operating capacity, not contract capacity, but operating capacity. So I got a 100-megawatt contract, but maybe over 7 years, they're going to operate at 50% capacity. And so your load ramps typically, when you ask a customer for a load ramp, they never stop at 50%. They're always significantly higher. And so you need to know that the length of time, and then ultimately it's utilization rate or capacity factor. Where are they going to end up? Because nobody runs at 100%. Nobody. And so you have to factor that in. I think the third thing is you also, in all our contract queues, if you're, I think the IRP is 15 years. You don't have signed contracts, firm contracts for a 15-year forecast. So you have to look at some of those engineering contracts in our case and make assumptions. How many of those are going to actually ultimately result in meter set? And it's been our experience that percentage of conversion is a lot lower than people typically think. And so those are the way to think about when forecasting by contract. We learned that. We grew through that. We don't do that anymore, but we have a rich treasure chest of meter data that most people don't. The last thing I would, so that's capacity versus demand kind of contract forecasting. The last thing I'll tell you is we have learned there's no silver bullet to managing this, and it grows very fast. It's ever changing because it's technology. And so you have to have a combination of bullets. That's a bad analogy. I was going to say silver bullets. There is no silver bullet. You need a combination of solutions to address this. You need good tariff design. Our approach is take or pay. You need a good contracting structure to make sure they're just not lingering, but they're going to connect. You need to change things in your terms and conditions, at least in Virginia. We instituted deposits for long lead time equipment. You need good policies. We're probably changing a policy literally every 4 months because you put something in place and then the industry turns, or something in the industry changes. And so you're always having to change something. And that's very radical for utilities because you never want to change anything. We've got a long history of the policies didn't change for 20 years. We're literally changing them every 4 months. And then every biennial review, we have to file changes to accommodate and make sure we have regulatory support. And so none of that's bad. There's just no silver bullet. You need a combination, or your quiver needs to have multiple arrows to help manage this. And I say all this, data centers are not bad. It's great growth. It's enabling our society, but these are, as utilities and commissions, how we have to manage this growth for the benefit of everybody.
And that kind of, your response leads me to the question it looks like on your slide 7, when you talked about forecasting. And I made a note that you talked about kind of, I think, lessons learned from forecasting, and that you want, Dominion wants to have accurate and conservative forecasts. And I assume that's, of course, to protect customers from the risk of stranded assets. But with the conservative forecast, is there also, I think there's a balance, of course, because is there also a risk if you have a very conservative forecast that you may not have the transmission and the generation in place to meet the timelines for the data centers? What is that balance that Dominion has learned or is practicing?
So our forecasting methodology is, as I mentioned, is statistical. And so we do quite a few scenarios. So we forecast our largest and or fastest growing 7 customers out of 54. We forecast 7 of them. 4 of those are big cloud giants, the name brands, you know, and then we look at the other very large customers on our system. And we model them individually, statistically, and then go look at market information to make sure has something changed. Several years ago, our fastest growing customer on a percentage basis for 3 years, fastest growing, they ran out of investor money. They weren't a big player, but they ran out of investor money and they just ground to a halt. So if we forecasted based on history, we'd presume the same growth, but that wasn't going to happen. And so we forecast and then validate with market information. And then we take all remaining customers, forecast them as a group, because they're all competing then. You know, most of the, I think the term was build to suit or multi-tenant. They're all competing against one another. So we forecast them as a group. So we don't have to pick which one's going to win. And when you add all that together, that we deem that our high forecast. So that's our customer level forecast. It's high. One of the things we've learned is the more customers you forecast, the higher your forecast gets. The second thing we do, that's our high scenario forecast. The second thing we do is we do a low scenario forecast and we model the aggregate industry statistically. We don't break it out by customer. We just look at the grand total over time. And we actually forecast by month out 20 years. And we have data back to 2013 by month. So we're forecasting industry in aggregate, and that yields a lower forecast. So we've now got a high and a low forecast. And our approach is we average those. And I use the term conservative. The accuracy of this method has been proven, I think, on 4 gigawatts of demand 2 years out, we're with plus or minus 200 megawatts. To give you an idea. And the closer you get, obviously, the longer you get out in the future, the more inaccurate it gets. I get that. But we have found that this is highly accurate. So we do a high forecast, a low forecast, and we take the middle scenario. In most cases, we're slightly under forecasting. We've had a couple cases where we've slightly over forecasted, but it seems to work. Well, I know it works. So.
And I think we could probably have a discussion all day about accurate forecasting, but in the interest of time, I'll move on. I think, Mr. Gillespie, the next questions I have, I believe, are for you. Starting on page 6 of your slides, there's discussion about the construction letter of authorization and then the electric service agreement, and talked about deposits that are required or payments that are required. What guarantees are there to ensure that the payments are made? For example, if and same thing, and I'll go ahead and ask the next question about related to find the slide that you discussed it. On page 10, you talk about the minimum demand charges. How do you ensure that the data centers or the large load customers actually pay for all of this? What guarantees are in place? My concern is if the company went into bankruptcy or went out of business, how do you protect the utility and the customers?
Sure. Let me take that second one first, and then Mr. Blackwell can address the ESA and the deposits. So what guarantee are they that there is there that they would pay the minimum demand charges over time? So if you look down there below, so we do require a 14-year contract. And what we do is we look at okay, so you're requesting 100 megawatts. So we forecast what would be the minimum demand charges based on our current rates over that 14-year period. So that's what they're committing to. And then we are requiring that they put up collateral when they sign the ESA. And so we have proposed $1.5 million per megawatt of contracted capacity for collateral. And that would decline over time as they move through the 14-year contract. We would release 1/14 of that over time. So that could be either through a parental guarantee, surety bond, letter of credit. And so they are posting that collateral upfront at the time of signing the ESA that would cover their minimum demand charges over the remaining part of the contract.
Okay. And also related to the minimum demand charges, what you're requiring is 85% minimum for transmission and distribution and 60% minimum for generation. Why does Dominion not require 100%? How did you arrive at the 85% and 60%
Sure.
thresholds?
So 85% represents what you would expect under normal operations for a typical data center to use over time. So if they're asking for 100 megawatts, their meter demand is going to be 85 to 90%. So what that represents is they're actually utilizing the capacity that they've requested. I mean, in their normal business operations. So really the intent here is to ensure that they're actually ramping up to what would be full utilization. We understand 100% is really not full utilization, right? So it really is geared towards ensuring that they're ramping up, they're asking for the capacity that they're actually going to use. It puts a financial stake there for them to not over request capacity. And then, as I mentioned earlier, the 60% is a little lower because it's less site specific. It's a little more fungible across the system. And we are building, I didn't mention this before, we are building or planning for generation to the meter demand, not necessarily their contracted capacity. So in other words, they're asking for 100 megawatts. We'll build a 100 megawatt substation. So from a T&D standpoint, we're serving 100 megawatts, but we're planning to the orange curve that Mr. Blackwell showed, the meter demand, which will be less than the 100. So it's a little bit of a discount on generation.
Okay. And I'm going to try to move through pretty quickly. I've got a couple of questions about the rate design and the rate classes. And for the high load customers, the demand is 25 megawatts or greater. Can you discuss how 25 megawatts was determined? And then second, in addition to that, it would seem to me that having a lower threshold, like 25 megawatts or somewhere in that range, would provide greater protection to existing residential customers or different rate classes. Is my understanding correct that having a lower threshold would better protect existing customers?
So we'll probably tag team on this answer. So let me give you a simple example. One of the reasons a lot of utilities have 100, 150, they have different sizes. We chose 25, and I'll give you a real life example. So there's two data centers. They're right across the street. They're mirror images. They both ask for 300 megawatts of energy. All right. But Commissioner Tucker decides he wants to meter that. He just says, I'm going to have 300 megawatts, but I want 30 different accounts and meters. Very common. It's how he wants to meter his site. But you decide, I just want one meter. I'm going to take a 300 megawatt transmission level meter. So the customer decides how they want to meter that. But from an electrical standpoint, there is no difference between those two sites. And utility regulations are written on accounts, number of accounts, meters. And so we made it 25 megawatts because we didn't want customers to be able to meter themselves out of our high load proposal. That's why we went there. The second reason is, because we're kind of the birthplace, for lack of a better term, of the data center internet industry, we have a lot of legacy accounts that are smaller, but they still consume a lot of power. And so those were two of the factors that drove us down there. And I think the last thing is we actually went and looked at all our high load customers just to eyeball and say, are we in the kind of the ballpark? But those are the three reasons why. And I'll let Scott.
Yeah, that's perfect. And just to add context, so we have approximately 450 data center accounts. So by setting the 25 megawatt threshold, that captured approximately 130 of them, maybe 131. So that leaves 300 or so accounts that are below 25 megawatts. So what this is designed to capture are the larger of the customers. So had we set that at 50 megawatts or 100 megawatts, that would have excluded a larger portion of those. So it really is looking at our customer mix, what accounts we have. We certainly want, in creating this GS5 class, we want some, I'll call it depth to the class. You don't want just a couple of customers. You want some depth to the class to ensure proper cost allocation and rate design. I think the final part of your question was, is the lower that threshold is, does it provide additional security against stranded cost risk? And the answer to that would be generally yes, right? The more customers that we have paying minimum charges, providing collateral, providing long-term contracts, that provides additional security. Now, I will add though, however, I think going forward, as Mr. Blackwell said earlier, almost all of the new connections are going to be 100 megawatts or greater. So what we would expect, whether you set it at 25 or 50, I think you would expect going forward, most, if not all, of the new data center customers would fall under that threshold. But 25 worked for our system and the customers that we currently have.
And Dominion is not proposing to have a new rate class in North Carolina. I think that in your comments, you stated that there is not sufficient interest from data centers in locating in northeastern North Carolina in Dominion's territory. Help me understand why it's not a better practice to be proactive and to go ahead and get the rate classes in place with the assumption that data centers will be coming to that area of North Carolina.
Sure. So if you look at our current customer mix in our North Carolina jurisdiction, there are currently 3 customers that are 25 megawatts and above. If we were to set threshold at 50, there would be 1. We have, in my belief, our 6 BP rate class very appropriately designed for those customers. We have no data center development, no data center customers under development currently in our North Carolina active development. So essentially, we would be designing a rate class for nobody. Makes it very difficult to allocate costs and design rates when there's nobody in it. So I think that's where, and if there were data center development in our territory, you would still have 3, 5, 7-year lead time before they would be able to connect and get through that contracting process. We would have the ability to come back at that time and design a proper rate. So I think it's just premature without any customers that it would apply to.
Okay. And then moving on, in the interest of time, about questions about co-location. And in your comments, you mentioned that one of the data centers in Virginia does have co-located generation. Can you talk about what that generation is, and does it supply what percentage of the electricity demand does that co-location provide for the data center?
Yes, ma'am. So we do have one customer. They wanted to get power quicker, so they choose to bring in their own gas generation. That property happens to sit adjacent to a pipeline, so it was a very simple connect. It's in a very urban area, so the mere fact that they were next to a gas pipeline enabled that. If you had to extend gas pipe in an urbanized environment, it would never happen. So it was a very unique circumstance for that customer. Their generation and load is under 100 megawatts. So just to put that in perspective, and the whole contract for them was built on temporary generation. They have been very clear with, by the way, they put their island. There is no connection to the utility. So they're on their own. We don't provide any backup service. If that generator goes down, that's their normal power, then their backup's available as with any generation. So it's very, very unique setup, and 100% of data center, I talk to data center customers every day. Every one of them tells me the same thing. I do not want to be, our company doesn't want to be in the generation business. We want power from you, the utility. And so that's the only one we have. We've had a couple ask about it. It's not a real practical solution unless you're sitting on a gas pipe. It just, that's where it falls apart. And so, we got one, and we don't expect to see another. I'd be surprised in the next 10 years if we see somebody else do that. Quite honestly, the other problem is you can be next to a gas pipe, and then you got to buy firm transportation.
Mhm.
So if you build them 100 megawatts, they really have to get really good at their load ramp and buy firm transportation in those increments. And if you don't get it right, you don't have gas. So those are the practical problems with that type of solution.
And then my last question, and I want to turn it over to the other commissioners because I've been asking a lot of questions, is so the data centers are not interested in co-location. What about, we don't have the regulatory construct for it in North Carolina. But are data centers asking for some sort of third-party PPA type of arrangement or some type of transition tariff? Like I think you were in the room yesterday that we heard some of the intervening parties talking about. Is that something that has been, that you're hearing interest from the data centers to provide a temporary solution or a bridge to being able to providing full generation from the utility?
I think generally the answer is yes, there is interest in that concept. And I mean, anything to bring speed to market is what they're interested in. I think we've had those conversations. I think the challenge, and you sort of alluded to it in maybe a question yesterday, is how do you, at least as a utility, how do you do that? But also, what do you do with the generation after the service is provided and getting into the stranded cost issue? So there is interest. I think it's early in terms of how we're working through if that could be something that's viable.
Mhm.
The other consideration there is, let's say you build a data center because the utility can't provide you generation quick enough. We still have to build transmission infrastructure to you. And so that is the only way you're going to get the power from that PPA. And so the lead time for service is dependent both on having generation as well as transmission. So
And in Dominion's territory, what is taking the longest at this point? Usually it's building the transmission, but it seems now that it may be constructing the generation to power the facilities. Is that accurate?
But yes,
Right.
both. Yeah.
now at a customer level, let's presume you have generation exist, but you need to extend wires, transmission. The longest lead time item that we see today is local permitting for a substation. And what happens is, at least in Virginia, the state doesn't have jurisdiction over the permit for the substation, the locality does. And so for data center friendly localities, the permit, you have a normal process. But if you don't want that data center next to your school, the locality has all the power, because if you can't put the substation there, you can't provide power. And that's is becoming, at least in dense urban environments, the longest lead time items.
Okay. Thank you for answering all my questions. Let me check to see questions from the commission. Chair?
Yeah, no, I changed my, it was too obscure,
Okay.
but I want to talk to you all about it.
Happy to do so.
Commissioner McKissick?
Just a few questions, and it sounds as if by creating this separate entity that's dealing exclusively with data centers, like Mr. Blackwell, I take it you're the one in charge of that capacity that's been created. You got a better grasp over the forecasting that's taking place. You're the primary source of contact for these data centers when they're coming into Dominion's territory. And it sounds as if in terms of this whole issue about speculation that you're addressing it through what I would call kind of a financial self-selection almost, because you're initially looking at this $250,000 deposit that's being required for doing the engineering. And let me ask a few questions about that. So they pay the $250,000. You're doing the engineering at that point. obviously it depends upon the location of the center and what's entailed, but does that usually cover all of the engineering expense? I know at one point you indicated that they could get a refund back for what might not have been utilized.
Yes, sir. We kind of did a system analysis. What's the average cost to engineer a data center? And that we established that 250,000 based on that.
Okay, and then the next step, you're going into the construction authorization. And at that point in time, I think you indicated $1.5 million that goes in. Is that right? Or is that, maybe I misunderstood something?
Yeah, so that 1.5 million of megawatt, Mr. Gaskell
That's what it
mentioned,
was,
that
yeah.
was our collateral requirement.
Collateral
But that
requirement.
was $1.5 million of collateral per megawatt over a 14-year time period. It's about $107,000 a year, roughly,
And
per megawatt.
got it. And based upon the megawatts of a typical center, how much would they actually be paying at that time?
On the collateral?
Yeah,
Well, so our hope is that they never draw, we don't have to draw upon the collateral.
mhm,
It's a take or pay concept. And so
Okay.
let me draw a simple example. Let's just say your minimum, you ask us to build you an 100 megawatt data center. And so we say 85% of that, or your minimum demand is 85 megawatts, 85% of that. If your meter demand doesn't hit 85, okay, then we're going to bill you 85.
got it,
If you meter at 90, then you're going to pay 90. So it's a floor.
got it,
So every month, we're going to render you a bill. You didn't meet the minimum in your question. We're going to bill you at this minimum, and we will do that every month.
got it,
If you go, I don't want to pay this bill, I'm going bankrupt, which I think was one of the questions, we will then call that surety bond or letter of credit, and we will call that for the remaining term, the remainder of the 14-year term, to make the system, if you will, whole for that 14-year contract. But again, our hope is we never have to call the collateral.
got it. Very good. And as I recall, I think you indicated between the engineering, letter of authorization, and construction, you give them only a 90-day window, is that right? Or
Yes, sir. We put that in place because first, we have an obligation to serve, so we have to engineer projects. And what happened, we went through a period, we were engineering projects, and then you, the customer, would take that and you would go out and try and find an end user. And we would just have this project lingering for several years. And, the engineering group's going, well, when's load going to start? It kind of grinds to a halt in your system planning. And that wasn't helping everybody. Plus, I'm reserving capacity for you, and there's 45 people behind you. And so we put that in place to say, if you're serious, McKissick Data Centers, then you have 90 days to construction. If you don't, we will cancel your project, move it out of the queue, and go to the next person in line. We didn't want to do that, but when you're trying to push, 40 megawatts through a pipe, we're required to do that to keep it going. We didn't want projects plugging up the queue.
And once you implemented that policy, were there a number of projects that kind of disappeared, fell out the queue, or what happened?
I can count on one hand the number that
Oh, really?
decided they didn't like that. I
Interesting.
got fingers left.
And if you were, as we are in North Carolina at this time, I mean, what would be your strongest recommendations to us in terms of policies that we should look at, Duke Energy embracing, or if you end up with centers up in northeastern North Carolina, I mean, of course, I guess we'd be looking at doing something similar to what you're doing elsewhere in Dominion territory, but what would those recommendations be, considering the fact, you guys have so much experience with this and so much accumulated expertise and institutional knowledge?
Yeah, so let me start and give you a plug for Duke. So we, for several years now, Duke, us, Dominion Energy, Southern, Arizona Public Service, and AP, small group of utilities, we get together about every 6 months. We've been doing this to share best practices. Now, all of those markets are at different stages of development. Think of us as the grandpa. I got gray hair, so think of us as a grandpa. Some of them are new, but you get the point. And so in that, my point is we're sharing with them, we're here. These are things we're doing because of these issues we've run into over time. And so what my experience with all those utilities is they're not adopting 100% of what we do because their market's not like ours. But I can tell you, I get a call from the folks, quite a few of the folks in the room from Duke. We talk quite often, not just every 6 months, and they go, what do you think about this? And so I think they're tuning their program as we speak to meet their market's needs, which is different from ours. I'll go back to my quiver of arrows analogy. There is not a silver bullet. I'm mixing bullets and arrows. So my weapon analogy, how about that? But I think you need to take a look at your contracting process. You need to look at your tariff design, your policies, your terms and conditions. And also I counsel all utilities, back 20 years ago, in order to change a policy or any of those things at a utility, you had to go to the chairman of the company. Nobody would go to the chairman, so nothing changed. We don't even go to the chairman's office anymore. We are changing something every 4 months. Now, policies change every 4 months, and then we're going to the commission and for changes there, new tariffs and things. My counsel to utilities as well as commission is get ready to change because it's going to evolve very differently than it has in the past. That's been our experience. Did I answer your question?
You did. I mean, and I know it's difficult and challenging to sit here and suggest what would be best because every jurisdiction's different, market maturity is different, and I suspect capacity to adopt the types of programs and initiatives that you've undertaken are perhaps different. But it's been very helpful today to listen and learn about what you have done. And I want to thank you all for a very thoughtful presentation that's provided us with a great deal of food for thought.
Thank you.
Chairman Brawley.
Yeah, let's go ahead and put this on the record. In the internet, late 90s, there were 3 backbone providers, and that was the internet. It was opened up at one point during what was called the dot-com boom. If I remember correctly what I was told in a meeting, there were 118 companies that were determined to capture 10% of the internet traffic, and they were laying fiber optic cable like crazy. When that crashed, 90% of that newly laid fiber was dark. There was no traffic on it whatsoever. You said something earlier about the number of people that are rushing into the data center market. And several of those companies in the internet had raised a lot of money and would be able to write the kind of checks you're asking, but still may crash. I think there may be a data center crash as marginal players fall out. What would those things look like, and how do we insulate ourselves from the effects of it?
Yeah, so the steps we've taken is first, we're requiring cash deposits. We've kind of talked about as contract obligations with collateral backing. And so we put all those in place as the first step. Think of those things in the contracting process prior to meter set. And then I think, as Mr. Gaskell outlined, our high load proposal with the collateral requirements, $1.5 million per megawatt over a 14-year contract, is then the secondary defense for once the meter's connected. And then I'll let
Yeah.
Mr. Gaskell.
Well, the only thing I would add to that, if you look at the business, the end use for the data centers in our service territory, I think we're roughly 85% or so cloud computing, right? We don't have the AI training load. We don't have the cryptocurrency load. It's sort of your bread and butter cloud computer. So when you think about what is the potential impact of a market crash in the future, I think the cloud providers and I mean, that's a fairly steady business. I mean, that's going to be a use for a long time.
Yeah, I think the better way I would describe it, it's the market crash perhaps would be on the speculative build, not on your installed base.
Right.
That's
Yeah.
the way I describe it. And so we're putting protections in, not because we think that's going to happen, but because we think it's the right thing to do to protect against stranded cost and have adequate or proper cost allocation.
I'll tell you, I would end up talking to you about this for an hour, but let's don't do that. That's a good enough answer. Thank you.
And so Commissioner Tucker has questions, but we've come to the time to take our morning break. So we're going to take a 10-minute break. We'll go off the record and come back on the record at 11:08. Let's go back on the record and we will continue with questions from Commissioner Tucker.
Thank you, Presiding Commissioner Kim Wright. Gentlemen, thank you for being here this morning. It's been an interesting presentation. I just got a couple of quick questions. Sometimes I review your Wall Street calls just to see how the temperature is there with Dominion and Duke. And my question to you, I guess, Mr. Gaskell, is Mr. Blackwell's put in place by lessons learned, deposits, upfront costs for engineering, construction, and then through the entire ESA process. How was that received by investors there that you were somewhat securing the overall cost of transmission interconnection? Did that help your credit metrics any at all?
I don't know. It'd be hard to say whether it had a direct impact, at least in the short term, on credit metrics. I think it is received well in terms of securing certainly the high load proposal that we made, the deposits, in terms of securing commitments from the data center customers, as well as concerns that it's addressing bill affordability over the future. So investors look at that as well and say, what is the impact to residential customers going to be on the data center growth? The fact that we're putting mechanisms in place to address that issue is received very well from the investment community as well.
Yeah, to eliminate any possible stranded costs that are there. Prior to my coming on the commission previously, and I ask you this question for my own edification, there was a large solar farm built in northeastern North Carolina. The developer went around this commission and went to FERC and got the okay to have transmission interconnection to that solar farm. And the deal was facilitated by Dominion buying the power from that developer. And then all the electrons were shipped out of North Carolina and into Virginia, I guess, for data centers or whatever you need to use them for. And the North Carolina ratepayers were stuck with paying the interconnection and the transmission from that solar farm, I guess, into the Hampton Roads community or whatever, right over the line, wherever your jurisdiction was. We, North Carolina ratepayers in our state, had to pay for that interconnection and transmission. Are there any plans, because you said there's no real interest in data centers in northeastern North Carolina, are there any plans that you're aware of where you're going to have a developer build a large solar farms and go through that scenario about going around this commission and then having North Carolina ratepayers pay for the interconnection for electrons being shipped to Virginia? I didn't think that was very fair. As a native North Carolinian, it's a burr under my saddle. And of course, if you're willing to send Duke a check for the interconnection and transmission for that particular project, we'd be glad. I'm sure they'd be glad to accept it. But do y'all plan to do any more of anything like that in northeastern North Carolina?
So I'm not sure the specifics of the project you're referring to. Typically, a generation interconnection, those costs, whether it's the direct interconnection or any associated network upgrades, are assigned to the generator. That's typically how it works. So without knowing the project, if something different than that happened, I'm not aware.
I can get that information for you, sir.
Happy to look at that. That's the typical process. We do have a number of solar PPAs in our North Carolina jurisdiction.
That's what I saw.
Yep, there are a number of solar, and a lot of those were driven by, they were developed, I'd say, it's kind of between 2016 and 2020. A lot of those are PERPA contracts. There are other solar facilities locating in North Carolina. I mean, we look at the load growth that we're facing, not just, in the entire DOM zone. We plan our system and operate our system as one system. The electrons don't stop at the border. And so if there are potential solar or other sites in North Carolina that can be developed at a competitive price, we're interested in doing that. But I'm happy to look at that interconnection.
I don't mind you doing that. I don't mind you doing that, but I just think it's extremely unfair to have North Carolina ratepayers pay for the interconnection and transmission of those solar farms up in northeastern North Carolina in your territory. Granted, it's your territory. I'm not arguing that. But, the fairness of that, the developer being able to go around this commission and then having North Carolina ratepayers pay for the interconnection and the transmission. And I think it was contested at FERC as well. And of course, I can get you that information, but, I just bring that point up because I see what's going to happen. And you're like, Duke, you need every electron you can get, and I get all that. But I'm just saying, you need to pay for the interconnection and transmission if that power generation is going into the state of Virginia and not have North Carolina ratepayers pay for that. That's all I have, Presiding Commissioner Kim Wright.
Commissioner Vanderbart. Well, it looks like that's the end of the commission's questions. Thank you for your presentation and answers to all of our questions. It was much appreciated.
Thank you.
Thank you.
And with that, we will return to Duke's presentation.
Presiding Commissioner Kimwright, if you're ready. Again, Jack Durack on behalf of Duke Energy Progress, Duke Energy Carolinas. I'm going to immediately turn it over to our panel, starting with Jonathan Bird, who's going to provide an overview of the presentation, and then we'll introduce the panelists. Jonathan.
Thank you. Good morning, Presiding Chair, Commissioner Kimwright, Chair Brawley, and members of the Commission. I'm Jonathan Bird, representing Duke Energy Carolinas, Duke Energy Progress, where I currently lead the rate design team. I want to share a few opening thoughts, introduce the company's presenters, and then we'll briefly walk through the prepared slides and be happy to take any questions you may have. First, we appreciate the opportunity to present today on this important topic, which is clearly of interest to a lot of folks, as you've heard this morning and yesterday and in all the filed comments. We are experiencing a lot of growth in the Carolinas, and that is not restricted just to large loads. It's across residential, commercial, industrial, and manufacturing sectors. And that said, we certainly acknowledge that these large loads present unique challenges and opportunities. The growth we're seeing reflects the state's favorable business environment, which includes constructive energy policies and affordable and reliable electricity. The work of this commission, proceedings like this one, serve an important role in developing and maintaining those benefits for the state. Sunny weather and 72 degrees in mid-October don't hurt either. As we walk through our slides and answer your questions, we will try to highlight how our approaches have sought balance between prospective and existing customers, between economic development and the large load pricing concerns, and also reliability and being responsive to new large load interconnection requests. I'll note, as public staff summarized in its slide, we agree with, and quote, the goal of balancing economic development with safeguards and transparency. That's exactly what we're doing. In comments from other parties, you've heard a lot of ideas and thoughts about how to address these large load customers. And the company's been working and evolving our practices since the commission approved changes to our service regulations back in January of 2024. And I've personally been involved since that time. We've monitored developments and ideas across the industry, reviewed other utilities' filings and dockets. And over the past 2 years, we've learned a lot. And I think importantly, from conversations with customers, prospective customers who are trying to bring on these large loads, understanding the risks, the ramp challenges, and the interconnection challenges with bringing them online. So over that time, I've grown more confident that our approach is sound. That doesn't mean we're done. We've adapted over the past 2 years. I think the Dominion witness said tuned our approach, so that's happening. I expect that to continue, including potentially incorporating some good ideas we've heard in this proceeding. And as we continue adapting, I'm confident our current practices will be balanced and will reflect what's best practices around the country. Even more importantly, will be responsive to the particular time we have here, we find ourselves in North Carolina. So with that, I want to introduce our panel. Andrew Tate will be providing an update on our economic development activities. Alex Castle will be discussing the contract terms and protections for large load service agreements. I'll be walking through how these terms interact with our tariffs and provide good price signals and address cost recovery concerns. And Mike Quinto will be discussing some of the large load implications from a resource planning perspective. Mr. Tate, I will hand it to you.
Thank you. Good morning. My name is Andrew Tate. I serve as Managing Director of Economic Development for the Carolinas for Duke Energy. Our teams serve as embedded partners with state, regional, and local economic development organizations. Those organizations have their own goals and strategies.
Mr. Tate, can you pull the microphone closer to you so that the people in the back of the room can hear you?
Is that better? Our teams serve as embedded partners with state, regional, and local economic development organizations. Those organizations have their own strategies and goals around economic development that typically involve job creation, capital investment, existing industry support, sites and buildings. We go to great lengths to align with their goals and strategies and work in concert with the people and organizations that have helped achieve a high level of economic development success in North Carolina. The first slide that I want to highlight titled Carolina's Economic Development Pipeline slide. It displays a snapshot of our economic development activity as of October 8th, 2025. This slide captures all current inquiries, not necessarily requests for service. And we acknowledge that only a fraction of these will ever progress to actually receive service. We receive new project inquiries every week, and every week we have projects that advance to either terminate or loss or successful outcome. This pipeline is not to be confused with the load forecasting and resource planning pipeline that Mr. Quinto will better explain later. With that background, this slide, the project count color wheel on the left, I think does a good job illustrating the robust and diverse nature of the industry activity that we're seeing. It's not all data centers. It's coming from a lot of different places, and North Carolina has a history of success with both emerging and established industry sectors across this color wheel. On the right side, you'll see the estimated gigawatts associated with each of these project inquiries, and you will notice a load imbalance that's specifically attributed to a category called third-party data centers. And so we want to acknowledge that. You've heard several witnesses speak towards double counting or other duplicative scenarios. This illustrates what we're seeing, which is a high degree of activity in one particular concentrated area at this time. North Carolina's economic development growth is driven by strong, diversified industries. Key factors contributing to this growth include an intentionally business-friendly climate that's been fostered by the North Carolina General Assembly with advocacy and support from the governor's office. In addition to that, our constructive energy regulatory environment that's building on decades of success in that space have laid the foundation for this new wave of energy-intensive economic development opportunities. That foundation includes rates below the national average. It includes a reliable system, diverse energy mix of generation resources, and increasingly clean energy. Additional elements that contribute to North Carolina's success include workforce development partnerships with community colleges and university system, population and in-migration growth, critical investments in other infrastructure, proactive investments in sites and buildings from across the state, and targeted performance-based incentives, as well as North Carolina's mature and high-performing economic development structure and operation. As economic development projects have grown more energy intensive over the last few years, our role and influence in site selection process has grown. At the same time that our obligation to serve remains unchanged. As Mr. Byrd stated, these large load projects represent both an opportunity and a challenge. They bring jobs and capital investment to the communities that they locate in. And they can also be a force for changing the trajectory of a community that has sometimes been overlooked by the state's economic development success rankings. Our approach is focused on achieving economic development benefits, but also mitigating risk and striking the appropriate balance in that regard. Service regulation changes and revisions from January of 2024 that specifically enabled enhanced performance and credit provisions have served as the backbone for our opportunity to evolve and move in this market. We're cognizant of our position in the market. We're open to conversations about opportunities for improvement and also very focused on that balance. On the subject of co-location, I've spoken with well over 100 large load data center prospective customers in the last 2 years. And I've heard approximately a handful reference some type of co-location or self-supply generation that wasn't exclusively focused on diesel backup generation for emergency support purposes exclusively. The handful that advanced this discussion were proposing co-location primarily as a means to speed delivery. And in most of those situations, the speed to delivery involved a transmission infrastructure constraint, not generation capacity. The large load customers that we work with daily value certainty in generation resources, as opposed to the uncertainty that can exist in some markets when it's uncertain who's building the generation. Our customers expect us to provide the load to serve their needs. However, should any customer present definitive plans and ready plans for non-emergency self-supply through customer-owned co-located generation arrangements, our companies would implement appropriate measures to ensure both grid reliability and equitable cost allocation. Given the importance of energy supply to these economic development opportunities and decisions, it's crucial to recognize that the policy decisions here at the Commission will be increasingly critical to whether North Carolina continues to enjoy our current level of economic development success. If done appropriately, our energy policy decisions and approaches here have the potential to continue to serve as a competitive advantage for North Carolina in this space. I'd like to introduce Mr. Castle to speak in more detail about our contracting process and protections.
Thank you, Andrew. And good morning. As my colleagues have referenced, my name is Alex Castle, and I serve as Deputy General Counsel in Duke Energy's transactional legal organization. I'll walk you through the process mechanics and contractual arrangements that we currently use with large load customers, focusing on how we protect our existing customers through a combination of additive provisions to provide for both earlier demand accuracy and long-term accountability for these complex, high-impact projects. I think as the panel of Dominion presenters referenced with respect to their process, our approach is similarly iterative and evolving. Will be shaped by actual experience, stakeholder feedback, regulatory directives, and changing system conditions. Protecting existing customers remains our central priority, but we're always conscious of the balance that's required to ensure that the risks and accountability that we're asking new large load customers to carry are reasonable. We intend to check and adjust over time in order to refine our approach to right-size these financial and operational requirements and long-term commitments. Prospective large load customers follow a 3-step sequential process at Duke. It moves from study to letter agreement to ESA. Our current process includes prescribed timelines for customer action to help move ready projects forward, to improve our planning and forecasting, and to prevent speculative projects from occupying system capacity merely as an option. The study phase initiates upon customer request, and that would be also subject to qualifying readiness requirements. And that study will evaluate the infrastructure needs at the proposed site, assess the impact on Duke's transmission system, and review the short-term capacity and resource adequacy to serve the proposed load. At the completion of the study, the customer will receive the results and be tendered our letter agreement, which memorializes those results
Effectively, that is the how and when of the conditions to their service delivery. Upon receiving our letter agreement, the customer has 30 days to execute that document and return it to Duke. This letter agreement confirms the customer's intent to proceed, subject to explicit financial commitments. It identifies the facilities required to interconnect to the site and authorizes Duke to begin the work necessary to support the service delivery. It also sets the timelines for site energization and the planned load ramp for the customer. And finally, it establishes that capital advance delivery requirement for the customer to cover the cost of the required interconnection facilities that are refundable under the ESA upon meeting demand and energy milestones. Once that letter agreement is executed, parties move to the ESA phase of the discussions. The ESA is, as has been described, I think, with Dominion and by other presenters, that's our ultimate long-term contract for service, and that contains the bulk of the additional terms and conditions that are applicable to large load customers that have been enabled by our service regs. That ESA must be signed by the customer within 120 days of execution of the letter agreement. Moving to the next slide. Thank you. These incremental terms that are displayed and I think have been discussed previously within our contracts are designed to supplement and are additive to the terms within our applicable tariffs and rate schedules, the service regulations themselves, and also on top of the requirements from North Carolina law and commission regulations. They include both financial and operational components. With respect to the core financial components, we're requiring a minimum contract term of at least 15 years. We have minimum billing demand requirements that are set at 75% of the customer's contract demand. This is the take or pay arrangement such that the customer will have to pay at least this level of demand charges, which cover our fixed costs to serve them, regardless of their actual usage. The terms also include termination liquidated damages, which are the exit fees that arise from customer default, early termination, or demand reduction. These are designed to provide revenue stability for a specified period if the contract is terminated or reduced early. These charges provide cover revenue for the company such that we have some financial runway to hold other customers neutral from the revenue impact from the reduced load. Finally, with respect to the security posting requirements, customers have to deliver some combination of cash collateral, letters of credit, and/or parent guarantees to cover their obligations and any potential termination liquidated damages that may arise under the contract. Now, the relative requirements as between these different liquid and illiquid sources of security will depend on ultimate customer and parent creditworthiness. On the operational side, we have incorporated curtailment provisions for a limited duration within the agreement to enable the company to curtail the subject load for reliability purposes during that term. We've added this during a projected period in the late 20s and early 30s, where firm service may be impacted by the timing of new resource availability and planned increases to our planning reserve margins. Customers have options with respect to this contractual term, where they can select either 50 hours of exposure at 95% of their load or 100 hours at 50% of their load. There is an additional piece that's not reflected in the slides, but it is important to note that an additional operation component to our ESAs will be the updated technical requirements for transmission connected customers specific to large loads. These requirements have been developed over the past year based on data from industry working groups like the NERC Large Load Task Force to evaluate and mitigate the operational impacts from these loads, like rapid loss of load and other technical issues arising from the variable nature of their power requirements. These requirements have been informed by industry collaboration for us to better understand these loads and how best to manage integrating them into our system, and they will evolve as we learn more and adapt to best practices. Like our resource planning and with our other contract terms, we intend to check and adjust in this space. Our intent is to be consistent with our peers, to incorporate specific lessons learned, and to stay in line with new regulatory requirements and best practices. We view our total contracting approach as a comprehensive package of protections that both protect existing customers and fairly balance the financial and operational risks of integrating large load customers. As we referenced in our reply comments, to ensure visibility and transparency, we have filed with the commission our Form Large Load Letter Agreement and ESA for information. And we've committed to filing any iterative updates to those documents as these processes evolve. We'll also be filing all executed large load ESAs with the commission for information as such agreements actually materialize. As you can see from the slide, based on internal consideration in response to feedback from stakeholders, a large amount of it received in the context of this proceeding. We're currently considering other improvements to our current ESA, and any such changes would also be reflected in those updated submission of these documents. Thank you for your attention this morning, and I'll turn things back over to Mr. Byrd to discuss our pricing and commercial approach.
Thank you. Mr. Castle provided a deeper dive into the specific contractual terms and mechanics that we're using with large loads to protect existing customers. I want to step back and give a more 10,000-foot view of the rationale behind some of the provisions and how they appropriately address the cost and risk for these unique transactions. First, as we described in our filed comments, the cost causation model works. What I mean by that is the basic approach that we have used for decades is still effective and appropriate. We do not see the need for a complete overhaul or replacement for the basic cost of service rate-making approach. These practices apportion out the costs for an evolving mix of generation to an evolving mix of customers. And the loads we're talking about today certainly are large, but we also have a very large system, and we're planning to make large investments in central plants and transmission with or without these new loads. Mr. Tate touched on self-supply for a minute, and I'll be brief on this, but our focus on those is on fairness. We're happy to work with customers on ideas or programs that preserve that fairness, and the same thing is true as clean transition tariffs or by similar names. We're willing to work with stakeholders and customers to explore options that preserve that fairness and actually work, and the details matter with those programs. I think you've also heard a lot about large load tariffs or rate classes. The issue here is really one of form over substance. Our existing tariffs and what Mr. Castle described in our ESAs are in combination already doing a great job of reflecting cost causation to large load customers and protecting existing customers through all the provisions that we just reviewed, and they're consistent with what we're seeing in the marketplace. Nothing prevents us, however, from revisiting this in the future and pursuing new tariffs or customer classes in the future. As Mr. Tate described, flexibility is essential in this maturing market. The specific terms and conditions we've discussed were all implemented out of that service reg change in 2024. And in general, we were able to implement them more quickly than if we had proposed detailed contract terms in tariffs within an extended regulatory proceeding. And with respect to transparency, we've committed to provide updates to the commission if we make any material changes to our contract forms or the termination damage levels. Next, our contracting provisions are designed to appropriately manage planning risk within really two categories: protecting other customers if the loads do not show up, as well as if they do show up. So we want to hold those large load customers accountable for paying their fair share regardless. And I'll hit on those two categories across the terms that Mr. Castle reviewed. If the loads do not materialize as expected, our contract provisions are designed to recover the site-specific cost for interconnection equipment that may have less value if that exact customer doesn't locate at that site. However, for network and grid investments, our focus there is on making sure that we have time to effectively reincorporate those assets, those investments back into the IRP process in a manner that isn't detrimental to other customers. So our focus there is really recovering the carrying cost of those assets. That's what the minimum bill and termination damages provisions are intended to do. Both of these categories certainly create meaningful incentives for the large load customers to give us accurate demand and load ramp forecasts. We've talked a lot about forecasting today, and we think those provisions encourage improvements in that space. Finally, the last two on timing issues, refundable advances and curtailment provisions address some timing mismatch in the early years. The refundable advance speaks to that local interconnection equipment that we invest in and install before the customer's load comes online and the meter starts spinning and revenue comes in. That customer is providing those financing upfront dollars so that other customers are not harmed while we're waiting on the load to come online. Similarly, the curtailment provision provides an extra layer of reliability in the IRP process while we're making the central generation investments to serve the new load. So in combination, our pricing approaches are robust and create outcomes and rates where these large load customers pay their fair share. The expected fixed demand revenues from rates for these customers are sufficient to cover the costs of the core central investments to serve their loads. And just as importantly, our rate-making approach ensures these customers are part of the solution for long-term grid modernization needs. So as an example, if a large load customer in 2035 requires an incremental investment in new combined cycle resources, that customer is then in the rate-making process to cover costs for new generation in 2040, 2045, regardless of what those resources are, what they may cost, or if they're investments to replace aging units, future environmental regulations, or other growth. That's a really important feature of that cost of service methodology that benefits all customers over the long term. Now I'll ask Mr. Quinto to provide an overview of some resource planning considerations for large loads.
Good morning. My name is Mike Quinto. I'm the Director of IRP Advanced Analytics for the company. I'm going to share a perspective on resource planning and how we're integrating these large load customers into our planning process. First, integrated resource planning starts with our load forecast. So I'll go to the next slide. Approaching how we are integrating these large load customers into our planning process from an analytical perspective. Planning for load growth is not something new for the Carolinas. It's been a great place to work and live for many, many decades. As Mr. Tate pointed out, the companies maintain a robust pipeline of economic development, but in our planning process, we're only planning for a small fraction of that, with the emphasis on those projects that have progressed furthest in that process. The load forecast itself accounts for many aspects of these large load customers. First is the consideration of how these customers have progressed through that pipeline, which I'll discuss in just a moment. We are also considering how much of this large load customer growth can be explained by underlying econometric factors that are already factored into our load forecasting process. And finally, how these customers come in over time is another consideration. So as Mr. Tate pointed out, we have a robust pipeline, but we're not planning for all of that load all at the same time. We're planning for that as it would expect it to be come on, much like Dominion has pointed out in their presentation earlier today. The graph on the left of this slide represents some of those various stages of projects considered in our economic development pipeline, from our ESAs, our letter agreements, late stage and mid stage pipeline projects. This graph on the left is a snapshot in time that fed our 2025 CPIRP process. So even in the 6-7 months since that's progressed from the development of this load forecast, many of those projects have continued to progress through this economic development pipeline. The companies, as shown across the bottom, developed several load forecasts in the 2025 CPIRP process, considering the impacts for planning for various amounts of this economic development load. So shown across the bottom are the different economic development scenarios included in various load forecasts. The graph on the right shows then how we translate that economic development pipeline shown on the left into adjustments to our load forecast that's added to those econometric models for projecting our load and what we're eventually planning to. So overall, the company's planning process with respect to load forecasting these new resources considers only a portion of that total economic development pipeline and are assessing how to plan for portions of that across many different planning scenarios. This represents a balanced and reasonable approach for planning for large load customers in our planning process. Now turning to my next slide. So the company's resource planning process inherently has check and adjust built into it. A very important factor for planning for large load customers, along with all the resources that's needed for the system overall. The company's CPIRP is a 15-year plan that extends out to 2050 through carbon neutrality. Importantly, that plan, beyond being a 15-year plan, also recognizes that every 2 years, we're back in front of the commission with an updated plan, with an updated load forecast, updated resource cost, and need for those resources to serve the system on a reliable basis. Between those intermediate checkpoints, we're also in front of the commission with large load reports filed semi-annually with the commission on updates to our economic development pipeline and how those large load customers are progressing through that pipeline. Finally, before we turn any dirt on a new generating facility, again, we're back in front of the commission in the CPCN process to continue to demonstrate the need for that facility on an ongoing basis with the consideration of these factors. So as we continue to monitor the materialization of the load forecast and overall process of how these customers are coming onto the system, in our planning process itself, we also want to retain flexibility to manage that alignment between customer needs and incremental resources to the system while maintaining or leveraging marginal resources and retirement of aging assets on the system to match that timing over the long term. So if we look to the graph on the left, the graph on the right, this shows the total resources that we need are made up of various buckets. First being that load growth and reliability portion, and the second being retiring aging assets on our system. Retirements can be more flexible, and marginal resources that are smaller in nature can be flexed forward and backwards to help match the materialization of this load over time. If that load materialization is slower than what we're projecting, we have the potential to accelerate some of those retirements. If the load continues to be where we plan for it today or potential to exceed that, we also have the option to maintain those retirements and look for incremental resources in that intermediate time frame to maintain the reliability of the system. With respect to long-term investments, as brought up by several interveners and the public staff, over this 15-year period, of course, there's uncertainty, but planning for long-term resource-generating assets on the system is not new. We've served a dynamic customer base for our company's history. The large investments that these customers are making in our service territories give us confidence that they'll be here for the long term. However, we still continue to maintain a check and adjust ability on a long-term basis as well for planning resources as into the 2040s and 2050s. We will continue to have resources that are aging and need to be retired and matching customer needs with incremental resources at that time. On to my next slide for load flexibility and opportunities and limitations. Load flexibility is certainly something that we can use to integrate customers on an expedited basis. It is the company's experience, however, that these customers expect and are seeking firm service over the long term, showing a short-term willingness to participate in well-designed curtailment programs to expedite that interconnection process. Through this process, we'll continue to engage with these customers on innovative solutions for voluntary participation in demand response programs, and that'll be reflected in our future IRPs as future resources as we understand how these programs develop and the amount of participation and reliable capacity we can get from them. Building off this, the more you add of any resource, the less valuable they are to the system. The same is true of curtailment. The more of this curtailment that you are adding to the system on a long-term basis without having them become firm over the long term will necessarily require them to be deployed more frequently or for greater durations. A simple example of this is on our left. These are examples of our winter and summer 24-hour daily load variations. In the blue is a winter load shape, and in the green, a summer load shape. If you were to visualize just clipping the very peak of that winter load, you may cover a 1 to 2 hour time frame for the amount of load reduction that's needed from a customer to meet that peak load. As you continue to increment down on that, your duration of that event becomes longer and longer. It may spread to multiple days. It may spread to other seasons of the year. So it's important to consider how long-term curtailment factors into overall resource planning from a peak load perspective. On an energy perspective, these large load customers are filling in the gaps in our load forecast as well in non-peak hours. So that continues to be seen as we look at the graph on the right for our iterations of load forecast. This is the total energy served. has continued to increase since we filed our original 2023 CPIRP in August of 2023. So with increased energy in those shoulder periods, we have less ability to move energy in time as another consideration for load flexibility. So while load flexibility is a tool in the tool belt, we are integrating this on a reasonable basis to understand how we can get these customers online faster, but to continue to maintain reliability. And we'll check and adjust future resource plans with voluntary participation in those customer programs. As was discussed yesterday and a little bit earlier today, the details of these all do matter. So how these are structured, the costs associated, the terms, the details of these different assessments can really play into maintaining the reliability of the system. And that's something that the companies are focused on. For my last slide, I want to turn to customer bill impacts that we're seeing. So Chair Kimmeray, or Presiding Commissioner Kimmeray, you've mentioned the narrative that large load customers are causing massive increases for other customers. Our analysis to date simply does not, we don't see that in our analysis to date. Mr. Byrd spoke a little bit about rate design and revenue requirement perspective on this. I'll address from a more macro perspective from resource planning. As you know, we filed our 2025 CPIRP on October 1st. In that plan, we can provide customer bill impacts. These are directional and illustrative, not really to be considered an all-in impact, but do assess the cost of the system for incremental new resources, changing costs for operating the system as well. And this highlights a key benefit of integrating these large load customers into our process. The graph on the left shows a range of different customer bill impacts that we've presented in the CPIRP. These customer bill impacts are presented on a compound annual growth rate. So how much year over year a customer could expect their bill to go up. So from the top end of this example, a 3% compound annual growth rate for customer bills, you would expect every year 3% increase on average. The two portfolios that we're highlighting here, first is our recommended portfolio from the plan. This portfolio includes more economic development load and the resources necessary to meet that overall system need. The green dot on the chart represents a moderate development load portfolio. So as we discussed, we developed several different load forecasts for the CPIRP. This portfolio specifically plans to less economic load, and as a result, actually has fewer resources to overall serve this system need. As we look at the chart, you can see that the recommended portfolio with incremental economic development and resources actually ends up with a lower compound annual growth rate to bills over the long term relative to a portfolio that serves less load with fewer resources. So from an IRP perspective, the cost of these incremental resources to serve the incremental loads is more than offset by those incremental megawatt hours to spread those costs over. Not only picking up the cost of the incremental resources themselves, but spreading the fixed cost of the existing assets on the system. So the narrative that large load customers are spiking customer rates, we're actually seeing that the opposite is true. Impacts over the long term have the opposite effect and are putting downward pressure on our rates, even when taking into consideration updated cost of new resources and changes in fuel costs over time. With that, I'll turn it back to Mr. Byrd for some closing comments.
Thank you, Mr. Quinto. Commissioners, thanks for the opportunity to provide some color on these issues. We appreciate the perspective shared by all the parties in this document and look forward to hearing from public staff as well. In closing, the state is well positioned to capitalize on these economic development opportunities thanks to the strength and reliability of our electric grid and our reasonable and competitive electric rates, which have resulted from decades of constructive regulation. Our recently filed CPRP, as Mr. Quinto mentioned, shows that we believe we can continue to serve this load and keep bill impacts at a reasonable level at or below the rate of inflation. With your oversight, we have already evolved to implement protections for existing customers for these large loads. And looking forward, the existing regulatory processes and mechanisms, including primarily CPIRP, rate cases, provide the perfect forums in which to continue to assess and monitor these issues. So thank you again, and we'll welcome any questions that you may have.
Thank you for your presentation. I'll begin with questions as I've been doing. Mr. Quinto, I'm going to start with you with what you left off with, and it was the same question that I started with Dominion. And on your slide 14, the statement is that the incremental growth from these large load customers or economic development does not, in bold letters, result in higher bill impacts. I think that's a really important point. What we're hearing, it's a widespread belief, is that data center growth in particular is in fact causing higher bills for existing customers. But the information that you've provided is that it will not. And I understand that there will be downward pressure on rates over the long term due to economies of scale. But in the short term, what about the short term? Will customers, existing customers, will they have to pay additional costs in order to build the generation, the transmission until the data centers or the large load customers are fully operational? And basically, I'm trying to, where's the disconnect? Because it is a very widespread belief about costs are going to be imposed on existing customers from the data centers.
Excuse me. I'll also ask Mr. Bird to jump in here from a revenue requirement on as these customers are ramping up. But it certainly is very dependent on how we're deploying resources to meet them. I think a couple of the interveners yesterday talked about your ability to utilize your existing assets to a higher utilization rate helps spread those fixed costs out over more megawatt hours. So depending on how that system is utilized and what it looks like over the near term and long term may change as you're adding resources to build into reliability requirements. Reminding the commission that we're working up to our 22% reserve margin. So we're certainly going to be adding resources in that time frame as well. So as you add more resources to get up to that time frame, it's going to put some pressure on rates to increase that reliability for the system. But again, over that long term, those megawatt hours that you get to an equilibrium is going to balance out from what we're seeing from our analysis in the CPRP. Jonathan, anything to add?
And before you move on, what is the time period from the short term to the long term where we can see those benefits of providing downward pressure on rates? How long? What is that time period that before that downward pressure on rates will occur?
We've calculated customer bill impacts in 2 years, 2035 and 2040. I'm presenting the 2040 on that slide. There's more information on 2035 impacts. There's also differences in how these portfolios are developed and how they account for reliability and risk adjusted over the long term. So unfortunately, we've only done 2 snapshots based on the amount of analysis needed. So I can't tell you where that crossover point is exactly, but it is over the long term that those begin to moderate as we get up to our 22% planning reserve margin.
If I may add a couple of thoughts on that. So it's a good question. There are a couple of different lenses to look at this. And Mr. Quinto is presenting the long-term kind of portfolio view. And what you see there is when a large load customer comes on, we're serving that customer. We continue to invest in the system. And maybe we installed assets to serve that customer in 1 year. As we continue to invest, that customer is picking up costs for future investments that continue to serve the grid. That's how we plan. That's how we serve is a grid-wide perspective, not at the incremental kind of individual customer, individual generator view. And I think what Mr. Quinto's view is looking at that portfolio, some of the things that are missed in those early years are refundable advance, or curtailment provisions. So when we look at those, when we're making those investments, we're trying to make sure that those customers' revenues match up with, or the revenues that would be passed to other customers match up with when that investment or that revenue comes from the large load customer. So we're trying to address that mismatch in the contractual terms. I also think it's important not to think about it as like a one-shot deal. It's not one customer and one new generator. It's a portfolio. So as we turn on new loads, new generators over time, year 1 for a particular customer is year 5 for another customer. So that kind of trajectory of revenue requirements and new revenues is a portfolio view, and I think effectively addresses those mismatch concerns as well.
And the data centers, what we hear frequently, and we heard yesterday, is speed to market is critical for the data centers. And I know that my question is going to, it's very site specific based upon transmission that's available. But it generally, after executing either, I guess, a letter agreement or the ESA, what is the general time period that that it takes to bring the generation and transmission and bring a data center online?
It's incredibly site specific.
Mhm.
But we've seen ranges as short as 2.5 years to as long as 7+. Just like some sites that we might see are more competitive for life science projects or headquarters projects. Those sites bring different assets and different pieces of infrastructure and value to any given project. The same is true for a data center project. It also depends on what level of flexibility they might bring, whether we're building the substation or providing a primary delivery at high voltage. There are a lot of different variables to consider that are adjusted in that timeline.
Mhm. Okay, and I want to move on to the 100 megawatt threshold that that is being proposed for the performance credit provisions for the large load customers. And can you help me understand how and why Duke chose 100 megawatts as the threshold and why it was not a lower threshold, just for example, 25 megawatts as a number that is used in Dominion for their tariff?
Yes, so before January 2024, the company in DEP territory had several large general service tariffs that had a cap of availability at 100 megawatts for a new customer. And so we filed with those service regulation changes a change in that availability criteria to allow customers above 100 megawatts to go on those tariffs, like LGSTOU. And so that kind of anchor point was historical for us. And we just said above that threshold, we're going to require these incremental performance and credit provisions. And that threshold was set for that very reason, because a very large customer dropping into an existing rate class could be problematic in the IRP or whatever. So that's why we selected that as initial threshold. I think we filed in our comments that we continue to review and evaluate whether that's appropriate. I did hear Mr. Blackwell's comments with respect to the 25 megawatts for Dominion. I was interested in his comment around, the metering and aggregation. And I will say in our service regulations, the language says that these provisions will apply to customers who are reasonably expected to grow to exceed 100 megawatts at one or more aggregated premises. So we're addressing that through that language. So if I do have, let's just use his example, 6 or 7 25 megawatt projects all in one space, we would apply these provisions in that case as well.
Now, that was going to be my next question about potential aggregation. But can you help me to understand as well, wouldn't there be greater protections for other customers outside of the rate class if you had a lower threshold? Wouldn't there be, couldn't existing customers or other customers be better protected if you lowered the threshold? Or am I not understanding it well enough? But it seems like that the lower the threshold, the greater protections to other customers and other rate classes.
I think it's a good question. It's about balance in planning.
Mhm.
And so when you think about the size of our system and the IRP, if I'm looking at a 10 or 15 megawatt project, that's not moving that planning process around like a 500 megawatt facility would. So it's about that individual project creating uncertainty in our planning process. That's the protection. We do have language in the service regulations where if I have a smaller project, perhaps like you're referencing, that creates a lot of more local investment requirements for interconnection. If those costs are outsized, then we would apply provisions similar to the large load customer to those smaller customers. But that's more focused on that local investment threshold, which becomes more of a concern with a smaller load.
Mhm. So I'm going to move on to co-location or self-supply that we've heard a lot about. And I think, Mr. Tate, you talked about how some customers, and I didn't catch how many large load customers have expressed interest in co-location or self-supply. Can you repeat that so I can know the percentage or number of customers that are interested in that option?
Just a few have expressed interest,
Okay.
and those have predominantly been focused on some sort of natural gas CT type of unit, and on occasion, battery storage as a tool. And when I say expressed interest, I mean they've considered it or brought it forward as a potential path to speed the delivery predominantly. We just haven't seen a significant amount of interest in that. The majority of these large load customers come to us with the expectation that we will provide that service. The other thing that I think is worth noting is of the few that have mentioned it as a possibility, no definitive plans with concrete generation assets for self-supply have been presented to us in a way that we could actually consider and model in a layered form with the interconnection request.
And at a high level, and I know this is a very complex topic and issue, but just at a very general high level, can you talk about the benefit would clearly be being able to provide generation more quickly to a facility that Duke might not be able to have the generation for in the time period that the data center would be looking for. But can you talk about what the issues? I think you talked about there would be questions about cost allocation and grid reliability. Are there other issues? And then could you talk about the other issues that Duke would be concerned about with co-location? And if not, just explain some of the concerns about grid reliability in more detail.
I'm probably not the right person to speak to grid reliability, but I will say that I think in every circumstance, the intent behind offering up the potential for self-supply or co-location of generation resources was to improve the delivery timeline. And in, I think, every one of those scenarios, the delivery timeline was constrained not because of generation capacity, but because of transmission infrastructure. So co-location and self-supply isn't always going to be a quicker path towards delivery. Mr. Blackwell noted earlier today the rare circumstances that have to occur with the convergence of gas infrastructure, or from a battery storage perspective, the fact that you've got to overbuild your transmission infrastructure to be able to accommodate that resource. Those are the types of complications that we see come into those conversations.
I would just add also there's the overlay of the applicable laws across both of our jurisdictions that we serve. One of the projects that Mr. Tate was alluding to contemplated third-party ownership of the generation that was not customer ownership. That implicates a whole different level of review, potential certification, other types of considerations that we have to be mindful of because at a baseline, whatever a customer is proposing has to be legal under the applicable state laws and recognition of our franchise rights and territorial assignment.
And is there a difference between the third-party owned generation and the PPA option, for example? And Mr. Drack, if I am going to be asking questions that will be coming up in another docket, please let me know, because we don't want to go there if that is the case. But is there a difference between third-party owned generation that you're talking about, and then also a PPA structure for that? Yesterday, we heard a lot of talk about the transition tariff, and specifically about the clean transition tariff. Those are two separate scenarios. Is that correct?
I think so. My understanding of the way that a clean transition tariff would work is that there's still Duke would be purchasing the power under the PPA, and that there's the customer is covering the incremental cost of any sort of attributes or, of those particular facilities that we otherwise would not procure. In the co-located generator context, there would be some sort of bilateral arrangement between the third party that owns the generation and the customer. So you end up in kind of a triangulated situation, and that co-located generator arguably is serving that customer at retail, which we have an exclusive right to do under existing law and under our territorial assignment rights.
In regard to the third-party owned generation that you're mentioning, and only if you know, but I assume that we would require legislation, change in legislation and the regulatory construct to allow third-party owned generation to supply energy to the data center.
Depending on the proposal that was advanced by the particular generator, that might be required.
Mhm. Okay, so moving on to flexibility and curtailment. And I believe it was discussed on page 8 of the slides. Excuse me, not page 8. 13. I'm hearing for Commissioner McKissick, slide number 13. So in your presentation, you talked about curtailment and that there would be curtailment provisions that have been proposed. Would those be mandatory curtailment provisions as proposed?
They are.
Okay. And what response have you received from the large load customers in regard to the mandatory curtailment provisions?
I think they understand the reason why we are imposing those conditions. I can't say that it's the most well-received of our terms. And there's a lot of discussion around the impacts on their plans for backup generation, their air permitting requirements related to that, and kind of how the mechanics of the way we would curtail them would work.
And in the way that you curtail them, has that you have not determined how that would be accomplished at this point? Is that correct?
No, we have a plan. It would operate, I think, similarly to our existing demand response programs, where there is a notice period that's implicated when we've identified a period where we would have reliability concerns. We provide notice to the customer. They have a window within which to respond and reduce their load to the prescribed level. If they don't actually do that, we can do that ourselves to force the curtailment at that point. There's no buy-through opportunity, and it's not optional. And then we would provide them notice when the curtailment period is set to end so that they can plan to re-energize their load.
Okay. Since Duke would have the ability to accomplish the curtailment, there would be no penalties involved since you could.
That's correct.
Okay. And the Data Center Coalition yesterday had some comments about that they want certainty in regard to, or more certainty in regard to what's being expected for curtailment, the number of hours. Has that level of certainty been provided to the large load customers?
So as large load customers move through our process and they're tendered our letter agreement, they get the general overview of the curtailment requirements, but the details are included as an exhibit to our ESA.
Okay.
So they get them once they advance to that stage of discussions.
Okay. And in your comments, this is about new tariffs. In your comments, you've stated that your position is that there's no immediate need for new tariffs for large load customers. Can you talk about why new tariffs are not appropriate at this time? And then at what point, under what circumstances, would Duke believe that new tariffs would be appropriate for the large load customers?
Yes, we have a couple of high load factor tariffs available today. So I have a high load factor tariff in DC, similar in DEP. Then we have other tariffs that are available for these large load customers. I think those tariffs work well in terms of appropriating the cost to those customers on a cost causation basis. We do that every rate case. We look at cost of service. We apportion those revenues out. We design the tariffs to recover costs based on cost causation. So I think that's working. In the testimony, I won't speak for Dominion, but in their testimony in Virginia, when they filed for that class, they said that cost causation was working and it would continue to work with the new tariffs. And that methodology stays the same. What they were doing was saying, we've got a lot of customers in that grouping. And so pulling them out into a separate tariff provides for incremental transparency. It was not actually, the way I understood it, adding to, or it wouldn't in our case, add to the protections that we already have in place. So we have those protections. They're effective. They're working. Cost of service is working. So it's just not necessary. Now, when could it become an option for us? When we have lots of high load factor customers that would look very similar, that would be dissimilar from customers what we have on LGS TOU or OPTV, it might be appropriate to consider separating those off. And I would say our cost of service methodology in the rate cases is kind of set up to do that already. Right now, those high load factor tariffs for DEC, for example, it's included in the OPTV primary rate schedule kind of grouping of customers. When I get enough customers on that HLF tariff, my cost of service folks will separate them out and give me cost of service revenue requirements that I'm going to solve for in the rate making process in the rate case already. So I think it would just be superfluous given what we have.
Will Duke continue, will Duke commit to paying attention and to whether there is a need for additional high load tariffs? Is that something that you will continue to monitor and determine whether it is necessary to come forward with a additional high load tariff?
Absolutely. And I would say the high load factor tariffs that we have, we're part of the outworking of a collaborative process with stakeholders. And so that's just evidence of our willingness to work with customers and keep evaluating them. So absolutely.
Okay. And then turning to the negotiated contracts. And so in your reply comments, you provided a template ESA. But my understanding is that some of these contracts are negotiated. They are not, that they can have different provisions for different large load customers. Is my understanding about that correct?
The core components that we've described to you today are included in every ESA, whether they're negotiated or not. There may, as you can imagine, there's some wordsmithing that goes on in terms of customers being comfortable with certain terms and conditions, but the substantive concepts are the same. Each of those ESAs is going to have a minimum contract term of 15 years. It's going to have minimum billing demand requirements set at 75%. It will have termination LDs applicable to the various load reduction scenarios. It will have security posting requirements to cover those termination LD requirements in the agreement. We'll have the curtailment provisions and anything else that we add as a necessary feature will continue to be required of any customer that signs an ESA with us.
And I think what the commission's concern is making sure that all of the contracts, including or agreements, including the negotiated ones, have consistent rate protections for existing ratepayers. And so can you just confirm or clarify that those ratepayer protections are in all of the agreements, including the negotiated ones?
They are.
Okay. And then at a high level, I think all four of you were in the room yesterday. Is that correct? I think I saw all of you here yesterday. Is that right?
I wasn't here, but I was watching.
Following online. Yeah.
Okay. Did you hear Mr. Tyler Norris's presentation at the very end of the day?
Yes.
Okay. At a high level, so he talked about curtailment and flexibility that he's recommending for Duke system. At a high level, can you talk about if anything that you would disagree with or that you think is not appropriate for Duke system so that we can have a response to his proposal to the commission?
Yeah, I tried to hit on it in some of my prepared comments. I think it is important to understand the long-term nature of curtailment on the system. The more of this you add to the system, the more of it you're going to have to curtail for each incremental customer. And that, as Mr. Castle points out, is a very contentious option as these customers are seeking long-term service and firm service for, well, how we would like to provide them. So, really looking at these as temporary is important, and integrating them on an expedited basis to maintain reliability in that short-term period as we're growing into our 22% reserve margin is appropriate, something that we're building into our planning process and considering, and how we can integrate these customers while continuing to maintain the reliability of the system. But we do recognize that, on a long-term basis, they have high load factors. They want to be served in all hours of the year. We want to serve them in all hours of the year with their obligation to serve. And that a well-designed voluntary program, that's great. If, we'll continue to work with these large load customers if they want to have backup generation on site, if they are willing to transition their computing or however they would achieve this reduction. That's something we're continuing to look at opportunities to engage with that and fairly compensate those customers for that service and the benefits for the system. But it's not something that, we think is something that should be mandated on these customers on a long-term basis from a planning perspective, for reliability, much less for how they would like to be served.
And Mr. Doris provided some responses to questions from Chairman Brawley, and I will just paraphrase what I think I heard from him. And I'm not sure that he was talking specifically about Duke's system, but Mr. Doris said that that he expects that load shed will have to occur with data centers coming onto the system. Can you respond to that for Duke's specific system? Will you have, or is the plan and commitment to have sufficient transmission and generation so that load shed is not an expected consequence of connecting data centers to the grid?
Absolutely. Our expectation is to serve these customers reliably and firmly on the long-term basis. I believe under Mr. Fitch's proposal or his assessment was that that these large load customers would be the first ones to be curtailed to preserve the reliability of the system. So while that's not a preferred method for anyone involved, I believe that's what he was getting to rather than anything else for the impact of the rest of the system.
Okay. And then my last question relates to some information that was provided by the NCEMC's Mr. Ragsdale. And he talked about the interconnection process. Were you in the room when Mr. Ragsdale provided his presentation or answered questions?
Following online.
Okay. And I'll just paraphrase. He talked about how Duke might want to treat the large load similar to the generation interconnection framework, and that large load projects should be queued like we do the cluster study through the North Carolina interconnection procedures. Can you talk about Duke's response to that proposal of queuing large load customers?
I can speak to it at a high level. Our retail large load study process contemplates a serial queue, which is consistent with the OAT prescribed serial queue for network transmission. I don't think we would view that a cluster study approach, as is used with generators, would be appropriate at this time for load. If you wanted a more detailed response related to that, we could certainly work on that. But I think from a comparability perspective, if we're going to do something in the retail space, we would do the same thing in the wholesale space to make sure that those processes were not discriminatory between those two sets of customers.
So, Mr. Jack, a further explanation would be helpful to be able to, for us to better understand why clustering or queuing the large load customers would not be beneficial or appropriate. Okay.
I will say, based on our experience with the generator interconnection process, the clustering process takes time and introduces a fair number of contingent cost allocations of facilities of the bulk network transmission system. We're not directly assigning cost for network upgrades to retail large load customers through our interconnection process. So that's one aspect of it that may be a little bit of an apple to an orange. And the timing component, I think, is critical here. The DICES process takes a very long time, and that's probably longer than how long we want to wait to process customers through our prescribed retail process, given the fact that we want to make sure that our intake, our studies, our results, and then our agreements are not impaired or delayed by a process that introduces a lot more variables because you've got a bunch of different customers that are all being studied at the same time.
And Mr. Drack, he answered my question, so I don't need any further explanation.
Nice
Thank
work,
you.
Mr. Castle.
So thank you for the responses to my questions. That's all the questions I have. I'll look to the other commissioners. Commissioner McKissick.
And I have just a few questions just to get some clarification. And now, of course, in listening to Dominion and their approach, they've identified Mr. Blackwell, who's kind of solely and exclusively dealing with the data centers. It's not kind of integrated in with all the other economic development activity that's ongoing. And of course, they deal with the low growth projections. Has Duke considered moving to that type of a model, or is demand right now for data centers in North Carolina not sufficient that you feel that that's a step you need to take at this time?
Commissioner McKissick, I can speak a little bit towards the structure that we use to serve those requests. We're currently relying on our existing operational structure of the primary inquiries coming through our economic development team, and then being transitioned to our large account management team for ongoing relationship support and maintenance. But what we have done is we've developed some specialized folks on both of those teams that are uniquely suited to work with the most complex projects like these projects. So while it's not a separate standalone team, the skill set exists inside our current structure with our personnel, and we're continuing to improve and add to the skill sets and resources that support those efforts.
And I'll,
Yes, go right ahead. Yeah.
I'll just add from a planning perspective, we do look at how these prospective load customers are, the different types of energy usage that they'll have on the system, and we build that into our load forecast. So we identify which of these are data centers, which of them have different load profiles, and factor that into how they're explained by our past experience in our load forecast or in our load that we've served to date, and then projecting forward how they are going to be served differently. So we do have some of that analysis on our IRP development side that looks at it from a load forecasting perspective, and actually from a resource adequacy perspective as well.
And of course, Dominion, their structure is somewhat different, but they have the engineering study where they require a $250,000 deposit up front. Now, I didn't hear Duke explain anything that was similar or comparable in terms of a front-end commitment dealing with that engineering design that has to be conducted. How do you all handle it so that I can kind of compare and contrast that approach taken by Dominion, and certainly, making certain that these companies that come along are actually paying their fair share of the work and analysis that has to be done in that engineering phase?
Understood. I think so our letter agreement serves a similar function to their design agreement and their facilities agreement. We just bundle it all together.
I see.
And in the context of that letter agreement, the customer, after receiving their study results, will basically receive the estimate for their interconnection facilities, and they have to pay us in cash the full amount of the cost of those facilities. So we're not asking them to pay for a deposit related to the design work that we need to do, we're asking them to cover the entire costs of the facilities in that advance payment, which will cover our design, our procurement, and ultimate construction work related to the facilities necessary to interconnect them to our grid.
And if I can add to that.
Yes, please.
We do at the intake phase, effective September 1st, we have a $100,000 system impact study fee that is similar to Dominion's fee. If that project progresses beyond the letter agreement phase, and there's a second facility study fee, that's a $150,000. There's a great deal of similarity in the structure, although the contracts may have different titles.
Got it. And as I recall, between your letter agreement and the electric service agreement, there's a 120-day window that someone has to execute.
That's correct.
Okay. And I guess that kind of also narrows out firms that are not serious about pursuing things.
That's right. I think what Andrew was alluding to with respect to our study process, we've been a lot more deliberate in terms of making sure that ready projects can move quickly, but not ready projects get out of the way. Because they, for the reasons that I think Mr. Quinto alluded to with respect to our forecasting and planning, at each iterative stage, as they move through from study to letter agreement to ESA, we're counting a little bit more of that potential demand in our planning. So we want to right size it so that they have more skin in the game as they advance to each stage, and that they're maintaining that level of readiness to move with us so that we know if we are ascribing more certainty to the fact that that demand may show up, they are actually showing us that through the relative quality of their project, the information they're providing us, the financial, both the financial resources they're providing us and the accountability that they're giving to us under the agreements.
And I guess that leads me to the next question. Obviously, we're moving toward the 22% reserve margin. And when you have these companies along, even when they make the commitments, they pay the funds up front, the project's moving forward, it's also requiring us to reevaluate how much additional reserve margin that might be needed projection-wise to, obtain that margin that we're seeking to obtain. So, I mean, how do you address that commensurate increase that's going to be inevitably required in terms of who's paying that cost, or does that cost get socialized?
Mr. Castle pointed out in the process of evaluating these large load customers, they go through some checks with the company as to make sure that we can serve them on a reliable basis as we're growing into that 22%. As they progress through that economic development pipeline and they become part of our load forecast, that becomes part of the overall system need for resources. And again, we don't ascribe specific resources to specific customers.
Right.
It's an aggregate system
Yes.
that serves an aggregate need. And that's the way that they get built into our load forecast is as they progress through that, they become part of our IRP planning process on the long term, making sure that in the near term, we can maintain reliability as we're growing into that 22%.
Okay. And of course, there was also mention of a distinction between the type of data centers that you have. And I think the term of art I heard referred to as learning centers, where there might be some ability to have some flexibility with load and hours of operation of data centers that are operating today within Duke territory. Do you have any that fall into that category, or are they all falling in the other category?
I don't believe so. I believe the bulk of them have a very stable load curve over a long period of time with a high load factor that you would commonly attribute towards cloud storage types of operations.
And do we have any capacity to know today when there's an entity that's looking at North Carolina, evaluating it for data center in Duke territory, how many other jurisdictions they're looking at? I mean, I understand that under Senate Bill 6 out in Texas, there's a disclosure requirement. so that there's some ability to know where else they're looking. Do we have anything that would drill down in and give us that type of insight to know, particularly among these third-party kind of speculative entities that are out there? I mean, other places they're looking so that when we're looking at this low growth, we don't know how many other places it's getting counted. So do we have any capacity to judge this, determine it, evaluate it?
So we're actively involved in conversations with those types of prospective customers on a daily basis. And we do not always know how many different locations that they might be considering. It's very common for a percentage of them to be looking anywhere and everywhere that they can achieve the load ramp that they're looking for in a cost competitive basis with a reliable system and speed to delivery. But also included in that mix is the person down the road that has a 150-acre farm with a transmission line that runs through it, right? So it is tied to a single piece of property or an existing building with an existing substation. And it's not a search all over the country. It's a very narrow target. So there's a wide range of opportunities that exist in that space.
And I'll just add, Commissioner, the load forecasting process does try to weed that out for what we're considering in there with the projects that have progressed furthest in that economic development pipeline from the ESAs and the LAs that have made more substantial commitments are factored in more heavily into our load forecast relative to those more speculative projects. On Mr. Tate's slide, I think it said 43 gigawatts worth of interest. You can see that from my slide 11. It's a much smaller portion of that, up to maybe 4 gigawatts by 2030 for total economic development in our forecast. So a small fraction of that is actually being translated to our planning process.
And I guess the last question is something I don't know how you evaluate it, if at all, in your analysis. And I'm increasingly hearing about data centers that are going into counties, seeking rezoning, trying to get the authorization they need to site the facility. And they're running into opposition. What typically do you see? How mature are those projects that I'm hearing about that are running into those obstacles and problems in terms of what I call the line of progression that has to be followed to get it to that level of maturity? Are these sites that are not gone through the level of maturity that I anticipate they might have? They're more in the early stages that are potentially more speculative.
I mean, we would view those as not as mature projects.
Okay.
From a development risk perspective, if they haven't addressed that, because that's a critical gating item for them. If they haven't addressed that, the relative readiness of that project is discounted. And I think Mr. Tate alluded to it, but in the way that we are addressing our study processes for our customer to be ready to move into our study process, we want to have some recognition of the relative quality of the project moving forward. We're asking for information from them about whether their project is a permitted use on the site and whether they have actually applied for rezoning to the extent that it is not currently a permitted use. We're also asking them to demonstrate site control, which is in many of these cases, they don't have. So we are trying to build up from an intake perspective, the requirements that these folks have to meet to try to make sure that whatever we're getting is real and mature and can be advanced at a normal state with reasonable expectations so that they can either make the decision to get out or move forward with us in the time that's required.
That's helpful. That puts it in context for me. Thank you.
Commissioner Tucker.
Thank you, Presiding Commissioner. Kim Wright, I'll try to be quick here, best we can. Thank you, gentlemen, for your presentation this morning. Mr. Tate, Good to see you again, sir. Today, if a viable hyperscaler wanted to put a data center in North Carolina, what is your projected speed to market? As far as that goes, I think we've had previous discussions that it could be as long as 6 or 7 years. Is that still the case?
It could be. It's highly site dependent, circuit dependent. Are we building the substation? Is the 230 kV line that has longer lead time for breakers, or a 100 kV line that would allow us to move a little bit faster? But incredibly site dependent. I would say that the range of possibility would be anywhere from 2.5 years to 7+ years. So a big range of speed to delivery depending on the location.
Okay. The 2.5 year customer that can get power because of circumstances with the site, et cetera, is that what the North Carolina co-op's talking about when they're asking for more transparency from Duke so that they don't feel like that hyperscaler would get preference over generation versus the North Carolina electric co-ops? Is that what I heard yesterday?
I can't speak to that. I think that what I heard was that there's an emphasis on comparability between the retail and wholesale process, and to make sure that one does not disadvantage the other.
Okay. All right, I'm good with that. Mr. Byrd, we are in a very different place. For 20 years, I guess the growth for electric generation was somewhat flat. And now we're in the 3, 4, 5%, depending upon who you're talking about. Why would that not want a change in the traditional cost of service procedure that Duke uses today?
So we plan as a system, we invest to serve the whole system, and we don't invest in particular assets to serve particular customers. And so I think that process is robust. That was the same process we used several decades ago when we did have higher growth rates. And so it's proven itself, I think, through times of higher growth and times of lower growth. I think it's a fair question. If I was a 1 gigawatt utility wanting to turn on a new 1 gigawatt single customer load, I would look at that perhaps through a very different construct and lens. That's not the situation we're in North Carolina today.
Okay. I just asked because, I mean, we're all caught up in data center, and I think, the market's changing quickly. Mr. Quinto, I was excited when you talked about the downward pressure for ratepayers until you said that probably would not come into place, if I understood you correctly, and correct me if I'm wrong, for about 15 years. Is that what you said?
There's certainly over the long term, that's what we see. We are in a position today where we have increasing reliability requirements. So regardless of any load being added to the system, we're going to need to add resources. So the more resources that we have to add on the fewer megawatts that we have to add it over can cause a mismatch in these customer bill impacts over time. So certainly on the long-term basis, as these new large load customers come onto service, they're spreading these costs for all these resources out. That's certainly the impacts that we're seeing. But we're in a very dynamic spot in our planning and execution where we have this increasing load, we have increasing reliability requirements, and to continue to serve the reliability of the system, it's going to be, necessitate more resources on the system to do that.
So the rates are going up for the ratepayers.
Rates will go up regardless. Putting aside any additional resources or load growth, we'll continue to see inflation of operations costs, inflations of fuel costs, whatever that may be. The downward pressure is the ability to spread that over more megawatts, which is helpful. The more megawatt hours we have to spread those costs over, the better.
Yeah, so the rate decrease will come when I'm pushing up daisies, I guess. Mr. Castle, you talked about certainty, and I was looking over some of the information we've had in this massive book here. In Kentucky, they require a 90% upfront bogey to get through the data center process and begin the process to try to cover all the cost. Now, there may not be many data centers looking to go to Kentucky, but, you know, I guess my question to you is where can we gather assurance that your tariffs, your ESAs, your construction costs, your engineering cost? I know Mr. Tate said for you to even look at it, you're asking to put up $100,000 bond or cash up front. Why wouldn't we go to that? I would flush out a whole lot of people that, you know, say that they're going to use 4 gigawatts as I guess he has in the queue now, if I heard correctly. Why wouldn't we go to a higher level to make sure that all the costs are covered and don't fall back on the ratepayer now or 15 years from now?
I think the package that we have is designed to do just that. Because from an earlier stage perspective, as a new large load customer is entering the queue, they're going to pay that initial fee, also have to demonstrate qualitative readiness requirements that won't even let them into the queue if they can't prove those out to us. They have to enter into specified study agreements with us to even initiate the study. Then after the study's over, we tender them the letter agreement. The letter agreement requires them to pay the full freight for their interconnection facilities, regardless of what that is, within a time certain after they sign that agreement. And that is going to cover the full balance of construction of those facilities. We have mentioned that there's a refund possibility in the future, but that's dependent entirely on their performance and their ability to demonstrate that they're covering their cost of service.
I get
over the
that.
contract term. And then also, I think what may be lost a little bit is when we sign an ESA, these the performance posting provisions, the termination LD provisions, they apply as of the effective date. So if they walk on day 2 or day 3, they are exposed from an accountability perspective to us to the tune of what's included in that contract. And for these larger loads, that can be a material sum of money.
Yeah.
And we're asking for that to be covered through a combination of both liquid, letters of credit or cash posted to us, and or parent guarantee to the extent that they have a creditworthy parent. So we have multiple levers to pull, multiple avenues to go down to make sure that we're made whole in the event someone doesn't continue with their project after they've made commitments to us and we're making commitments to them to serve them within the time specified under the ESA.
I was with a hyperscaler last week and they said that they would be willing to pay up to 75 or 80% of the cost of interconnection, transition, and generation. Have you heard a number like that in your dealings?
Not in any of the conversation that we've
We'll
had.
talk to Google, talk to Google.
we
'Cause
have-
they said it. And I'm gonna hold them to it.
We haven't been asking any customers to pay directly for generation or network transmission through our current approach. I think has been.
Publicly, it was stated before a lot of commissioners that they would pay that much, so you need to know that, and that's what's going on. Are you aware, or any of you aware that Microsoft had canceled data centers in Ohio and in Wisconsin? Are you aware of that? That, you know, with all the zeal and the fervor around data centers, some of them are getting canceled for one reason or another, but they were way deep into those 2 particular states and now they backed out. Anybody aware of that?
Yes, sir. Aware of that. And we obviously track headlines like that, but we also track the relationship with this industry in aggregate form. And we've seen some volatility in it, some starts and stops, some pauses, some let's go faster, let's slow down. So that's a component of the relationship overall.
Well, and Commissioner McKissick talked about the pushback some of the data centers are getting. Are you aware of the Pennsylvania county up in Virginia where they canceled a project, about 2,000 acre project that happened up there? Are you aware of that? I mean, all I'm doing is I'm trying to get to the point of saying, guys, don't overbuild. Don't get so caught up in all of this that you could do that. That's the only point I'm making. So it comes back on them. And even Georgia has taken away their incentives. Your ability to get them to speed the market motivates them more than state incentives. So, I mean, I think that's really key. I guess, Mr. Quinto, let me ask you this. A vertical utility would tend to want to, in my mind, err on the high side of putting in assets because it's a better return for their stockholders. I get that. That's just a fact of life, in my opinion. But for instance, in your planning, should the CAA 111 change and they're allowed to have the CCs run at 60% or 70% capacity versus the 40 that it's at now, wouldn't that wouldn't it be necessary that we would not maybe build another CC? Have y'all looked at that that would impact the overall asset? Would that be a consideration?
From my perspective, deferring to your judgment, I think Mr. Quinto could address this very high level, and then we'll.
Yeah, it's 40% is public record, and there's been press about the fact that they may raise the efficiency rating on a CC anywhere in the country, not at our carbon plant. So what's the answer on that, sir?
The base planning assumption in our 25 CPRP is that the phase two requirements under the 2024 greenhouse gas rules is going to go away. That's our base assumption. We have evaluated what's the impacts of that if that stays around. And we'll certainly see that in the CPIRP process. But we have evaluated removing that constraint when planning the system for this go around.
So there's enough flexibility in the lead time that you don't need to, you'll have enough time not to order the equipment if that does go away. I know Mr. Smith stated that some of the turbines that he's already got orders in with GE or whomever it is. I'm just asking, would you have to pull back without a large penalty if you've got one or two in the queue?
No, first of all, the structure for the reservations is flexible. It's a reservation slot for those turbines themselves. But the plan itself does envision what's the best way to optimize execution for planning for the system. And as I mentioned, that does consider the base assumption that restriction on capacity factor for those new gas resources go away. And it's something we'll discuss more fulsomely in the CPRP itself. But it's certainly something that comes into our check and adjust and maintaining flexibility as we're planning the system on a long-term basis, and what are those near-term actions that we propose in that proceeding.
Very well. Thank you, gentlemen. Thank you, Commissioner. That's all the questions I've had.
Okay, so that's all the questions from the commission. Thank you again for your presentation and responses to questions. We will now take our lunch break. We'll take an hour and we'll come back on the record at 1:50, and we will at that time proceed with the public staff's presentation. So that will go off the record. And let's go back on the record and we will proceed with the final presentation of this technical conference. I'll turn it over to you, Mr. Felling.
Thank you, Presiding Commissioner Kimwright. Commissioners, Tom Felling. I'm joined by Zeke Creech with the public staff on behalf of the using and consuming public. Presenting for the public staff today, in order from my left to right, Mr. Patrick Fahey, Mr. Dustin Metz, and Dr. Leah Weaver.
So good afternoon, Commissioners. Wait for the slide to load. Thank you. So a lot of the topics have been covered by the panelists over the last couple of days. So sake of brevity, that we will move efficiently through this overall process. The public staff has widely reviewed large load tariffs and proposals nationally. We reviewed 44 tariffs in 28 states and several instance reports in generation regions saturated with large load. Integration of large load customers must balance economic development and grid reliability. Large load has driven electric system growth, but with fewer, larger customers than in the past. High load factor customers, HLF, have unique operating characteristics and occupy a different role than traditional large general service or traditional industrial customers. With careful rate design, reasonable ratepayer protections will allow parties to prosper, support economic development, and ensure risks are mitigated.
So as Mr. Metz alluded to, we've already discussed large load thresholds for additional provisions at length, so I'll be relatively brief. But I did want to point out this figure we put together. We reviewed many tariffs and riders nationwide, and we've summarized the minimum threshold in 33 of those tariffs in this figure. And I know it's a little small on the screen, so there is a larger version at the back of your slide packet there if you need a closer view. But so this is a histogram showing that the height of the bar is the number of tariffs, and then where it is on the x-axis is the size of that minimum load threshold where the tariff begins to apply. And so you can see that Dominion in Virginia, their proposed tariff is at 25 megawatts, and then Duke is on there at 100 megawatts. And a couple additional points of context. So in South Carolina, their Energy Security Act had both a 20 megawatt and a 50 megawatt threshold. And then yesterday we heard from the Data Center Coalition that they would expect to see something in the range of 50 to 100 megawatts. And so the point I'm trying to make here is that a few of these tariffs had high values like Duke, but the vast majority of them are a lot lower than that. And then a few additional points I won't spend too much time on, but we know that the risks vary with the size of load. So as Duke referenced, bigger loads can have higher risks to the system. And so we think that a tiered approach might make sense. So we can increase the provisions for higher loads, but sort of address that variation in scale and risk. We also know that contracted load can change over time, so we need to have safeguards in place for reductions in load, not just for load dropping off of the system. And that how we define the load threshold in a tariff needs to consider aggregation of accounts. As Dominion described, there's potential for gamesmanship there. And so as the Commission and utilities think about those tariff designs, rate designs, they should be cognizant of how they're defined to prevent gamesmanship. Next slide, please. We also wanted to give you sort of a timeline context for how the regulatory framework works with this, with new large load customers coming online. So in this figure, you can see a large load customer executes some agreements, they eventually get energized, and then maybe in a resource planning process like the CAP-IRP we're undergoing, that load is identified and included in the load forecasting. And perhaps through that resource planning process, we identify the need for additional synchronous generation. And so that generation gets planned, it eventually comes online, and then that asset is useful for multiple decades, maybe 35 years in the case of something like a CC. And when that asset becomes useful, it gets entered into rate base, and ratepayers are paying off that asset over that entire useful life. And so, as has been discussed, there's the potential for underbuilding here. You can see that the large load has the potential to come online before that generation is built. So there's a potential risk of resource adequacy concerns. And then there's also an overbuild concern. So if that large load customer drops off sometime during its load ramp period or even later when its contract ends, that generation is still going to continue to exist and is still being continued to be paid off. And so there needs to be insight into how things are changing as they're changing, since this regulatory framework is a really long timeline, but large load things are changing frequently. And so that's why we are recommending that the commission continue to require those semi-annual load forecast updates. I also want to point out that this timeline that we're working on is quite long relative to how fast these large load customers can come online. So the generation we're building now, this 35-year synchronous generation, that is going to continue to serve our grandkids. And if instead of building a CC or something, we're talking about nuclear, something with like a 60-year asset life, now this timeline is pushing towards 2100. So people who haven't even been born yet are going to be paying off of that asset. And so just keep in mind that the decisions made today are going to continue to have ramifications for decades into the future. Okay, and again, we've heard a lot already from CERC and Dominion earlier today about risks to the bulk power system and these large load loss or transfer events. So I'll keep my remarks brief, but there are two main points I wanted to make. So with the large load loss events in Virginia and in ERCOT, these are from aggregates of smaller loads. So in many of the cases. So not just 100 megawatt customers and larger, but at times even 5 to 40 megawatt data centers that are acting in aggregate. And so the protections that come into place need to be planned accordingly. And then also this is a new and emerging dynamic. We're in a living lab and we're all learning together about how this works. Even in Virginia and ERCOT, where they've had data centers for a long time, this hyperscaling is an emerging issue. And so the data that, as Dominion said, having that data about what is happening in real time is critical to our being able to understand when these events do happen, what's happening, so we can try to prevent them, and then if they do happen, improve and work to be better in the future.
So as Dr. Weaver mentioned earlier, it's the length of time where we have a bit of a disconnect between the length of these contracts in that 10 to 15 year range and the length of time these assets are going to be recovered over. Those assets are 35 to 60 plus year lives, and these contracts are substantially shorter. So even if we have a large load customer who does everything right, they sign up, they follow through on their contract, and they continue on for even several years after the end of that contract.
Hey, can you pull the microphone a little bit closer to you so that everyone can hear you? Thank you.
There's still there's still people who are paying into the system at that point, 20, 30 years into the future, are still paying for these assets that we've added to the system. The result is that there's a back-end risk to ratepayers. So those long-term, very future distant ratepayers, if these loads leave at some point, again, in the longer term future, will end up paying for this generation that was incremental to serving these new customers that we have now.
I can expand on that concept a little bit more. I think you heard earlier today from the Duke panel, while I agree with them, additional megawatt hours help reduce overall rates to some degree to maybe prevent them from going as high. But as Mr. Fahey is mentioning is, if those customers leave at year 15 and we have all that capital investment that we had to build out, that's less megawatt hours that we have to distribute those costs. So the rates increases could be much, much higher than what we're predicting. Again, it's not to say that the sky is falling, but it's just to present to the commission that this is a potential reality, that one reason why we believe safeguards need to be incorporated.
And so one of those safeguards is advance notice requirements. And this gets into the communication that was mentioned and discussed with both utilities, between the utility and its large load customers. This allows earlier changes in those customers' plans to be incorporated into IRPs And it sort of provides notice and allows faster reactions by the utilities in things like their near-term action plans. So another one of the limitations that we identified was in the current Duke tariffs, as self-supply has been mentioned a number of times here, the idea that right now there are some limits on self-supply. As you can see in the slide, that sort of cogeneration or self-supply is limited in both DEP and DEC territories, and that there are benefits to ratepayers to allowing for this self-supply, in that if a large load customer is willing to self-supply and offset generation that would otherwise need to be built, then that risk of building and use of that generation is captured by that customer, not the utility or its ratepayers. And then finally, as has been brought up earlier, there are cost allocation and recovery issues that have broadly been discussed and need a lot of time and study. Generally, large loads are at a scale that can individually cause a need for incremental generation and collectively cause new generation need and are the fastest part of load forecasts and growth. But generation collectively serves load and provides ancillary services like frequency stabilization, and therefore the cost of new generation cannot be directly attributed to its large load customers, with transmission system upgrades similarly serving a collective load. Now, for transmission, substation, and distribution built to serve a specific customer, like a data center campus or large factory complex, it's not unreasonable for an individual customer to pay those costs to serve them. Whether that's upfront through the life of a contract or other methods is still very much in discussion.
So the main recommendation the public staff has for the commission is that they should recommend that the utilities suggest a large load tariff in their next rate case. And that's because we believe a large load tariff, along with an associated customer class, as described by Dominion, would provide more precision in our ability to allocate costs, but then also transparency to those prospective customers. As we heard yesterday from the Data Center Coalition and Google, that's something they're really looking for, is this transparency and certainty, and so that the customers can see upfront what the minimum terms are, and they'll be able to plan better, and it potentially could reduce speculative customers from entering the development queue. Having a tariff doesn't necessarily preclude Duke's ability to negotiate on a per customer basis with the ESA, but it does guarantee these ratepayer protections so that they're not subject to change from negotiation, and both the commission and prospective customers have clear insight into exactly what those provisions are. Now, we need this tariff to come in the next rate case, because as we've seen, large load is changing constantly. You can see in this figure, we've had 3 updates to the large load forecast in the last 2 years, and there's no reason to expect that won't continue to change. And then relative to that quick timeline, the regulatory timeline is relatively slow. So on this figure, the triangles represent a potential rate case being filed towards the end of this year and the CPIRP that was just filed. And you can see that when the rate years and that near-term action plan come into effect, aligns with when we expect to see this large load coming online. You can see that that expected demand is growing dramatically over that period. And so if we want that tariff to be in place when that large load arrives, it needs to happen now in the next rate case. I also want to make the point that even though Dominion hasn't seen prospective large load customers seeking to site in their North Carolina territory, the munis they serve have. So there's been a data center proposed in Tarboro, a steel manufacturer proposing to site in Hertford County. Those areas are right on the border with Dominion's territory, and there's no reason to expect that similar customers couldn't seek to site in Dominion's territory. And additionally, Dominion serves the munis that might serve those customers. So the best time to do this is now, so that we can get ahead of the risks and encourage economic development in a responsible way that protects already existing customers.
So let me first state, our comments should not be construed as Duke and Dominion are doing poorly. Rather, our comments should be taken as continuing improvements in the process while promoting transparency throughout. We're requesting additional safeguards, advanced notice requirements, exit fees, lower threshold for overall large load designation. And we want to work with the companies to determine reasonable safeguards. They have the pulse of what these entities are wanting. And from at least where my view is that we don't want to be over prescriptive and create unneeded regulation and potentially have unintended consequences of dampening economic development and future growth. The commission should require Duke and Dominion, as Dominion Energy North Carolina, to submit new tariffs for large loads in its next general rate cases. As Dr. Weaver pointed out, we believe now is the most reasonable time. Let's be proactive instead of reactive. And to the extent that we continue to wait, we already have cost of service potential impacts, and then we're playing catch up. We need to create new tariffs that match these loads necessary to utility investments, incorporate a transparent rate design, and ensure that large loads, high load factor customers pay their fair share and ensure potential grid impacts are appropriately considered via incorporating minimum contract lengths, minimum early notice deadlines, minimum termination fees that align not with the present cost to serve the system, but of the future cost to serve the system when these loads are expected to come online. We need to allow for a degree of flexibility in individual cases without unfairly hampering economic development. We recommend creating a tiered high load factor tariff structure that includes transparent rate design to ensure that large loads, high load factor customers pay their fair share for potential grid impacts and are covered by the correct customers. The tiered approach may be somewhat novel in concept. We believe it's appropriate given the potential risks. A 25 megawatt customer, I believe as a Duke panel stated, it's not a significant impact compared to a 2,000 megawatt, 4,000 megawatt hyperscalers that you're seeing in the news. So I think that should be evaluated and addressed in the overall future tariffs. The commission should require Duke's ESA contracts on new or large load tariffs to include specific advance notice terminations to utility for large load customers regarding any termination or significant reduction in load. Earlier notice will give the utilities flexibility to at least potentially refine those megawatt hours in order to keep rates reasonable or lower than if those megawatt hours leave. If that large load entity would leave on 1 month notice, it's uncertain, as we said here today, on how fast that next customer could come onto the system. Not even that specific location, but come onto the system. The commission required Duke and Dominion to provide updated load forecasts and respective IRPs and load interconnection queue status updates as part of their existing annual IRP updates. The Duke and Dominion should work with the public staff to develop additional safeguards to address longer-term risks for incorporation into these large load tiers. As we talked about today, the decisions that we're making will have impacts for certain generation assets into the 2100s. We do not take that lightly. We need to consider and implement thresholds for applications that prevent aggregation or gamesmanship. I think Duke had stated in their overall tariff of how they have language in there to prevent potential gamesmanship. That needs to be continually evaluated and incorporated. We don't want to set a bar that would relax the penalties, but then allow an aggregation of 25 megawatt facilities to potentially have the same overall impacts into the system. Duke reconsider tariff limits on maximum customer-owned generation and a net metering and propose tariff revisions to increase the nameplate rating of customer-owned parallel generation. Yes, the utility does have to serve these customers. And yes, the utility does have a responsibility to ultimately act as a backstop to serve these customers when that generation is not there. However, we believe that in some instances, with the utility knowing that they're doing so, that they can deploy their own capital, potentially bridge that, not bridge that gap, but they can generate their own power through what they want. For example, if they want to own, if it's a 500 megawatt facility and they want to own a 100 megawatt solar facility on the same land, they want to go through the interconnection queue, they want to self-generate, we don't see a harm in that overall process. So as long as the utility is made aware that it's doing and they study the overall impacts on their system. At Duke and Dominion should ensure internal protocols are implemented and validated for reconnection of outages for future large loads in the ESA. With Duke's panel presenting earlier, I believe they said around September 1st, they had a new incorporation which identified some of these protocols. So that is a positive attribute that needs to continue to be in place, and flexibility that these standards be updated through the life of the overall project and Duke not be penalized. And the commission to open a docket to require each utility to file an incident report with the commission in the event that a high load factor customer of a grid instability event or equivalent, and a summary of the corrective actions implemented following the event. We think it'll be informative to stay abreast of these informations, but I think what's more critical is the utility let us know of how they're preventing reoccurrences. That concludes our comments.
Thank you for your presentations, and also thank you for being here for the entirety of the technical conference and providing the last presentation for the conference. I've got a couple of questions, and I'll start with the one that I asked, the first question I asked of Dominion and Duke, because I'd like to hear the public staff's perspective of what I talked about is the widespread belief or perception that data centers coming to North Carolina and other states is going to result just because of the data centers being located in the states is going to increase customer bills to retail customers. Does the public staff have that same concern? We heard from both Duke and Dominion that that concern is essentially that the data centers will pay their fair share. And that there will be downward pressure on rates at some point in the future that will benefit all customers. Tell me what the public staff's perspective or position, if you can, about that issue is.
So that's a compounded question and has to make a lot of assumptions of what the future may be, which is difficult. So I'll start with the first point. Overall rates are increasing. I think Dominion did a good job showing this, I believe, in their last IRP. They said, if we build out this capacity, it's two tables in my mind. If we build out this capacity expansion plan, this would be the rate impacts to customers. In other words, this is our load forecast, and these will be the rate impact to our customers. And on that same page or near that same page, it says, well, if we get the megawatt hour sales from these high load factor customers, and again, public staff, we're calling high load factor customers, not necessarily data centers, this would be the overall rate impacts. So let's just say rates would generally rise at 1.5% to 2% per year. With the capacity expansion plans, rates are going slightly elevated more than that with the overall megawatt hour sales. Now, if those megawatt hour sales go away and we build out these plans, then rates will go up much higher. The second part of the argument there, or not argument, but I understood the question, was looking at will they pay their fair share? I think that's tied back into the cost of service. We're not proposing incremental rate making, so the cost of service is intended for them to identify their fair share of the overall system cost. That is not synonymous that they're paying their full freight for incremental generation or incremental load. So I just want to make sure. So sometimes when people are introducing those two comments, they might be muddying the overall water. There was a third point, but I strayed afield and I've lost it during my rambling here.
Well, let me ask you about the cost of service methodology. The commission, Duke and the public staff and the commission, we considered the cost of service methodology in the last rate case, if you recall.
Yes.
Okay. What is the public staff's position about when the cost of service methodology should be re-examined?
Oh, we need to consult with my team on that one, so I don't necessarily have a public staff position. But I would outlay Dustin Metz's personal opinion. Those should be evaluated on each general rate case. However, as a general, not philosophy, but something that we have to be cognizant about is if we set rates in this rate case under this cost of service methodology, and that caused a shakeup of overall rates. And then 3 years later, we decide to change that cost of service methodology again, you're going to have another rate shakeup. So the public staff has general principles that we try to do parity and rate alignment and et cetera. So if we continue to modify the cost of service methodology, you're kind of chasing your tail to some degree because you're moving too many variables and you're also having to balance potential rate shock implications in each case. So as I sit here today, I can't say with 100% absolute that we're following the exact same methodology. We just have to be cognizant that you might be careful of not wanting to actually shift the cost of service methodology in every general rate case because you could be creating unintended consequences.
And Mr. Metz, correct me if I'm wrong, but the public staff is recommending that new tariffs be developed for these large load customers, but the public staff did not make a recommendation that the cost of service methodology needed to be revisited at this point. Is that correct?
In terms of our statement, yes, the overall cost of service methodology will be reviewed and discussed in a general rate making proceeding.
Okay, so I'm going to move on then to your first recommendation about that Duke and Dominion should submit new tariffs in the next rate cases. And you were in the room when Duke's witnesses answered questions about why new tariffs, when I asked why new tariffs are not necessary at this point. And to just very much paraphrase what Duke's witnesses stated, they said that they believe that it was not necessary because there are already protections, mandatory protections in the ESAs, and that they would consider new tariffs if the circumstances warranted new tariffs. Do you recall that information?
I do recall.
And how do you respond to that? Is that something that you would agree with Duke about?
I do disagree, but I understand the logic that we're getting there. I think it gets into a different, slide's gone. Looking at the overall slide, we showed that graph of if we decide to do nothing in terms of a new tariff in the next 3 years, the large load is already going to be here. They're going to be under a different tariff design. We are trying to be proactive, add transparency overall process. And allow my colleagues to jump in here that we think Dominion's process in Virginia with GS5 it checked the boxes on a few elements, and I'll stop talking here one more second. It added transparency in the overall process where everyone could see the information. Mr. Fahey, Dr. Weaver.
I would add that again, there is this variability in load forecasting that others have touched on. Who will show up, who won't show up, and how that will change even in a relatively short time period means that when we can get ahead of this and establish something that helps set guidelines as to what the large load customers can come in to expect. And that gets into potentially improvements in forecasting and a better understanding from that customer's perspective of, especially if they're cross shopping against different states, what they have to expect in each region.
And Mr. Metz can correct me if I'm wrong, but I don't think we've seen an analysis of these large load customers and how creating a new customer class could benefit or harm the rest of the customer classes. And so that's something that we think is worth evaluating in this next rate case and trying to understand whether or not a new tariff for these large load customers and creating a new customer class for them would be beneficial as well.
And the other mitigant there is, let's just say we continue to place everything within a generic large general service or industrial class, just to be generic. Well, an industrial customer, let's just say that while important, they operate at a 27% load factor. Whether it's 100 megawatts or 15 megawatts or 1 megawatt. customer who operates at a 90% or higher load factor has different costs on the overall system. Part of this evaluation or consideration is also looking at not just interclass subsidies on a cost of service standpoint, but intra-class subsidies. And that way, these discrete profiles are paying their respective fair shares, and we don't have this customer being socialized by this customer, et cetera.
And your recommendation is to have a new tariff or tiered. I think your specific recommendation is to have a potentially tiered tariff. And do you have any examples of a tiered large load tariff in other jurisdictions? Is that something that has been implemented in other states, to your knowledge?
Dr. Reaver?
Yeah, just give me a second to look at my tables. There are examples of that. I don't know if they use that name for it, but let me see. So, for example, I see West Virginia Appalachian Power Company. They have two sort of high load factor, large load tariffs, and one is for a minimum contract load of 1 megawatt, and one is for a minimum contract load of 100 megawatts. Portland General Electric has a similar thing where they have these different levels of load, and maybe your minimum billing demand changes as a result, and your contract length gets longer the bigger the customer. So there are a few examples of that, and I know there's also a few that are under development as well. And then there's also examples of within the same tariff, maybe having tiered billing demand. I'm trying to remember which one that was. I think that's AEP Ohio has different tiers depending on the size of the customer for that minimum billing demand. So there's a couple examples for you, but I'm sure there's others.
Okay, thank you. And then in regard to the public staff's recommendation that a new tariff or some version of a tiered tariff should be considered in the next rate case. From a practical standpoint, the rate case is already, I'm assuming, going to be a complex and complicated proceeding. So practically, does the public staff, does the commission, do we have the ability to consider in a thoughtful way to make sure that we get it right what these new tariffs should look like? Is that something that we have without much time before the rate case begins, is that possible?
So the short answer would be yes, it's possible, while complex. I believe it's more appropriate to review tariff changes within a general rate case when everything is when everything is open, and then you can see when I throw this rock, what ripple gets created. You can do that outside of a general rate case and make recommendations. But typically, we like to do those within the confines of a general rate case and have it coming out of a general rate case. And that way it goes through a proceeding, it goes through the commission, then we can answer potential cost of service impacts to the commission.
Thank you. So moving on to the ESA contracts and Duke's panel, I asked the question about whether, the ESAs have some negotiated provisions. I think you were in the room when we discussed that. Is that correct?
Yes.
Okay. And so my question that I asked them was, are the customer protections included in all of the negotiated ESA contracts? And the response was that those were mandatory provisions and were included in all of the negotiated ESA contracts. Are you satisfied with Duke's response about those customer protections being included in the negotiated contracts, or do you still have concerns?
Mr. Fay, you go first.
I would say that in the aspect that each of those specific provisions that Duke listed are in each of those contracts. As far as I'm aware, I'm comfortable with that. That doesn't necessarily mean there aren't additional or other ratepayer protections that could be added to these contracts or other methods used to increase the protections for ratepayers.
I would just add that the public staff hasn't reviewed all of the ESAs to be able to say what exactly they contain or do not contain.
Not every single one, correct?
Okay.
And then just for a little bit of context there, I started kind of recommendation sections is, again, our comments aren't meant to be construed that the utilities are doing poorly. We're just wanting to make some fine tune enhancements. I mean, as an example, we need to make sure that some of these protections, the liquidated damages, et cetera, are appropriate and they align with the same time series that these projects are expected to come online.
And that leads me to my next question. I think it's page 5 of your slides when you talk about that, the issue of generation assets. I think, Dr. Weaver, you mentioned that generation assets may have, for example, a CT generating unit would have a useful life of about 35 years, and Duke's contract term has been proposed to be 15 years. So that leaves 20 years in which the asset would still be operating. So help me to better understand the public staff's position about where the issues are, because Duke's the information that they provided in their presentation is that for both transmission and generation, that the large load customers will pay their fair share. So my assumption is by paying their fair share is that they will pay for the cost, their allocated cost of the generation over the course of the life of the contract. Is that the way you understood their presentation as well?
Yes.
Okay. And so help me to understand the public staff's concern then about the contract term being less than the life of the useful life of the asset.
Sure. So there's a balance to be had. I mean, we're not going to make contract lengths be 35 years. Then we wouldn't have these customers wanting to site here. So we recognize that there's a give and take there, and we can discuss those things with the company as they're developing them if they decide to, or if a tariff is developed. There are things like that we can discuss about what the correct number is. But the public staff's concern is that if that customer, they do everything right, they show up, they take their contracted demand, and then 15 years come up and they decide, you know what, like, we don't think this is a good business decision anymore, we'd like to leave, that those assets are in rate base. And so everyone is paying for them, and they will continue to be in rate base for however long after those 15 years. And so it's just something to be mindful of, that even though these companies are paying their fair share cost of service, they're paying that cost of service for the time that they're on the system, which may be shorter than the assets themselves.
And what's a compounding factor here is this is the mere amplitude of the capacity that's being requested. I mean, traditionally, I would say this would just be the normal course of business. Projects come on, projects come off, generation comes online, generation comes off, et cetera. But I mean, as Dominion stated, they had over 4 gigawatts of data centers connected to their system. When we have to build out those levels that were shown on that slide, that is something that we have not traditionally done since the 70s or 80s. And then if the customers do everything that they're supposed to do and leave, more likely than not, Duke is still going to seek cost recovery for those assets. And we're trying to put in safeguards for today's customers and future customers who also want to potentially locate to the state of North Carolina.
Yeah. And perhaps I may have some misunderstanding. So if I do, please correct me so that I can understand this correctly. So my understanding from Duke's presentation and the information that they provided is that, so I'm talking about generation specifically now, is that the large load customers would be responsible for paying their allocated cost of that generation. So if they had a 15-year contract, over that 15-year period, they would pay for their allocated share of the generation asset. Is my understanding not correct about that?
That would be correct under, yes, whatever the company essentially closed the plant, allocated, that would be what they're paying for. But again, Yes, I'll answer your question.
Okay. And so what are the additional costs that you're concerned about, since the cost of the generation asset would be paid for during the term of the contract?
So I think the primary point is the concerns that once all this goes away, what is the system going to look like then and potential rate impacts? That's just making sure that the commission is cognizant of that overall risk.
Okay.
Now, in terms of the cost, we're probably very limited on what we can do because we want to continue to use the cost of service, but the commission's very well of life cycle costs of these overall assets. So let's just say for a CT, we have a large critical failure of the overall turbine that happens on year 16. Well, future ratepayers are going to pay for that turbine upgrade. Those costs necessarily didn't get passed on to that individual ratepayer who's left the overall system. That's just something inherently that exists today. I mean, environmental regulation could be another good example that when we built these particular generation plants, let's just say coal ash, that they paid for their cost of service that were allocated to them. We had changes in overall regulation. Today's ratepayers are having to pay for those costs, that coal ash, that they never consumed that megawatt hour that created that gram or that pound. I mean, that's just an inherent risk when we do these types of items.
Thank you, Mr. Metz. That's helpful. And then moving on to the other topic we've talked a lot about, which is self-supply or bring your own generation. We heard from both Duke and Dominion that these large load customers have shown little interest in self-generation or self-supply. Have you been hearing, do you have any other information about some additional interest, or is this a possibility that we think might actually be come to fruition in the future?
I guess I've heard it from both ends of the spectrum. Usually it's associated with well, there's two prongs: speed to market. They want their own environmental attributes for the overall generation. And then there's what I'm seeing in reality. And what I see in reality doesn't align with the other two conversations.
Mm-hmm. And what about third-party generation and the tariffs, the transition tariffs that were, this one that was specifically mentioned yesterday was the clean transition tariff. Are those other opportunities that could provide benefits and savings to customers if they were if they were appropriately prepared and approved?
It is possible. I remember looking at, I believe it was Nevada's clean transmission tariff approximately a year ago, or 9 months ago. So I'm a little bit rusty around the edges. But something to keep in mind is that, let's just pick onshore wind as a hypothetical example. You may pay a premium for that resource today. And so if total cost to serve you are just linear and going to go up over time, let's just say they rise at inflation, that you pay a premium for this resource, but then you're locked in. Well, guess what rates continue to do? So at some point, they're going to be paying a lesser cost than the overall system, or could be. And so that means that you have other customers now have to pick up that difference as the system has changed, and you have now planned your system around that essentially forced in resource. That's not to say that the clean transmission tariff or the CTT is wrong. It's just something that we have to take into consideration of what is that premium? Will they pay for the full life of that asset? In other words, are they going to sign a 30-year contract for 15 years? Maybe. Then what's going to happen to those tail end costs? Are we going to see cost recovery of those from the ratepayers, et cetera, from the existing ratepayers?
So I think what I'm hearing from you is that any type of tariff like that would need to be appropriately structured to ensure that there's no subsidization to those customers from existing or other customers. Is that in a nutshell? Is that what your position is, or the public staff's position? Okay. And then what about third-party generation? And I'm not talking about the PPAs, the clean transition tariff, but third-party owned generation that's provided to the large load customers.
So are you talking about a merchant power plant and then a potential wholesale-like arrangement?
Correct. Which is, my understanding is not permissible in North Carolina at this time. But we did hear recommendations yesterday about that type of arrangement as being a possibility.
I can't opine on state law in regards to that matter.
And to the panel, in regard to data center flexibility, we heard a lot about that over the past 2 days. Is there any additional information that you want to provide about things that the commission should be thinking about flexibility, and also to respond to Tyler Norris's presentation yesterday afternoon? Is there anything that the public staff would like to bring to the attention of the commission?
So I'll take first shot, and please don't take these comments as being critical to anyone during the panels. That I think we're at an interesting crossroads of looking at something from an academic exercise that would pencil out on a bus bar curve versus what CERC talked about, that we have to handle everything in real time on milliseconds at a Hertz cycle. Where is that balance? As Dr. Weaver mentioned, we're a little bit of a living lab. Like, we haven't seen these magnitudes trying to interconnect and these magnitudes that potentially drop off the system. So yes, from an academic standpoint, if we can shave off some of those peaks, then that could potentially reduce some of the generation assets that we need to build out. But at the same token is that we have to have enforceable measures that they actually get shut off. So let's just say we take a 300 megawatt load and it's a meter. Let's just say it's a meter. I don't know Duke is going to go in there and says, here's a switch that turns off 125 megawatts of your peak shaving. It's behind the meter. I don't know if Duke wants to go behind the meter and start shutting off certain aspects of customers' load. Yes, I can shut off the full 300 megawatts. I can open a recloser, and maybe that will potentially have another ramification to the transmission system that we have to consider. But it is a very complex item that's require more degrees of conversation. I believe Duke, at least Duke, to my knowledge, I'm not as familiar with the Dominion side of, they have curtailment provisions in there, but I think there's finer aspects of how much can be curtailed, when they get curtailed, and the enforceability of those options.
And last question, I think this will be for you, Mr. Metz. This relates to the reliability aspect, and the public staff has recommended that the commission require the utilities to file an incident report with the commission in the event of a grid instability event. Is that sufficient? Does the public staff think that the reliability risks, including the 2024 reliability incident in Virginia, requires additional action? What would be the public staff's recommendations?
So I think the first step of the process, and I know it's a theme, is just transparency. I think we need to have better insight to what's going on. I mean, for example, today we heard Dominion talk about 2 events, the 1500 megawatt event and the 1800 megawatt event. Now, I don't know where the 1800 megawatt events lives in NERC space. I'm only generally cognizant publicly of the 1500 megawatt event. And to the extent that we're kept aware of these overall events, it would also give us insight to how the utilities are adapting, and also what potential remedies, which will more likely not have costs associated with them, to resolve these overall items. To the extent that our states around us kind of pick up on this, I think that would be if I could dream for a day, then everyone would have this overall information, and we can see what our neighbors are doing. And that way we can see if they're having any instability events. Just because an electron or a plant is right across the state line, the electrons don't stop. They're going to come into our system, and no different than our system is going to go into their system. So we're all connected to the grid here.
And my last question before I check with the other commissioners, The three of you have been here for almost 2 full days. Is there anything that you want to bring to the commission's attention? Anything that you want to dispute what some of the other parties have said, or that you want to emphasize to the commission? I want to give the public staff this opportunity.
Dominion was saying earlier today how with all of their experience dealing with large load customers and data centers specifically, that they've found having a variety of tools at their disposal is important to be able to meet this challenge. And I would agree with that, and think we need to think about all of the different potential opportunities and tools we have at our disposal to best solve this problem.
Essentially mirror Dr. Weaver. As many tools, if we can come up with new tools or reevaluate how we're using existing ones, make comparisons to better analyze what is going on and these rapid changes.
So 2 prongs. I thought I heard my understanding of some of the panelists was let's move faster. I'm not comfortable with that. I'm not for fire, aim, and be ready. I'm more like ready, aim, then fire. We need to have a plan in place, which utilities are enacting, before we just go and figure out all the pieces afterwards. Stated differently, I'm not recommending to go build 10 gigawatts of generation just to say, here's a sign that says, come park your business here in North Carolina. There's a lot of different aspects that we need to work off and make sure that we have the safeguards in place. Another aspect that was raised, and while novel and potentially could result in efficiencies, was the overall load interconnection queue. So I thought I understood someone to say is, hey, let's merge the generation interconnection queue with load and do that on a cycle. I'd be very apprehensive as I sit here today to do that, just because I think Duke did a good job of trying to explain that is the generation interconnection queue is a challenge in itself, and that took a while to get to that point in time, and it required state and federal approval, especially when we're doing the general interconnection queue, DICES, and as well as resource solicitation clusters, that we're now starting to see the spider web or clear connection between the two. If we have a fallout from DICES, it creates potential restudies in the resource solicitation queue, and we know this process goes on, and we know this is requiring multiple restudies. Imagine now taking in load with the degree of speculative projects that Duke showed on that one slide. You may unintentionally, again, not to say that the sky is falling, further freeze the overall interconnection queue, which we have collectively worked on very hard to get more efficient. Now, the other concept of that is like, well, let's just have a standalone load interconnection queue. While novel, it does have its possibilities, but I thought Duke did another good job of explaining that is like, well, we now need to consider regional or NC retail specific, South Carolina retail specific, and as well as wholesale concerns. I would need to work with my legal team to understand of what type of animal that would create, and how long would that create, and is this be cutting something for a new cloth and will be pioneering in the overall process.
Okay, thank you for all of that insight. Chairman Brawley?
Thank you, Commissioner. 2 questions that came up, and one on page 9 about self-supplying generation. And it seems like someone else made the comment about freeing up people's ability to provide, provide their own power. If we did allow, say, a 300 megawatt data center to supply itself with 300 megawatts, are we also still having the must-serve requirement on Duke that should that 300 megawatt fail, Duke would have to supply that load? Or would we be changing the law to make them an island where they're providing their own power and they are outside of the rest of the system?
So the first part of it, I look at it is if I'm a 300 megawatt facility and I want to own my own 300 megawatt solar facility. And let's just say the tariff allowed it, they went through the full interconnection study and it was allowed. But yes, in theory, how I understand it is that Duke would still have to backstop them and even address the potential intermittency that that facility, regardless if it's solar or even if it's a combustion turbine, things break. Duke would still have to backstop them. Potential mitigants could be is that they're on a transmission schedule. In other words, they tell you we're generating X, so that way you know as a system operator of what you're getting and when you're getting it, and it's pre-approved. And if you get a deviation, again, paraphrasing, it's either get the boot or you get the stick. In other words, a penalty.
Is public staff advocating that data centers should be providing their own power to limit the stranded asset risk? Or is that just put out as a theoretical construct to think about?
We are not advocating that they have to supply their own generation because it gets into the overall backstop. What we identified is that it appears to be rather arbitrary in nature to limit self-supply in this magnitude. And should we be thinking ahead of saying, well, when we made these assumptions, and again, I don't know why it was logical to limit, let's just say a 1 megawatt self-supply to a 100 megawatt facility. We're looking at newer, larger loads, 500 megawatts, 1 gigawatt. Continue to hold everything at those prior interconnection limits while reasonable, whatever they were, conclusions at that point in time, they're not scaling with the load that we're seeing to interconnect. I think we need a degree of flexibility to further modify that amount. But I think that it would require conversations with the utility to say what is an allowable amount. For example, going further deeper down in the weeds, I think you heard a conversation of, well, if we connect to a 100 kV system, there's limitations that we can do on a 100 kV system compared to a 230 kV system. So I think that needs to be considered too when we're looking at the supply. I mean, a good example could be a 44 kV system. I'm not going to put a 100 megawatt facility on a 44 kV system, generally speaking, or a combustion turbine. I'm just using solar as a hypothetical. I got a lot more room on a 230 kV system. Why does the tariff have to be that prescriptive versus we can have a degree of flexibility in the portions of the negotiation process?
Well, I think one problem they have is they're talking about 50% of their load being data centers in just a few years. I don't think we're facing that much. There was one other question. Dr. Weaver, I think this is the first time you've appeared before us. Welcome.
Thank you.
You made a comment about nuclear power plants with a 60-plus year useful life and that people not yet born would be paying for them. I was thinking that was implying that we were going to limit Duke to recover the cost of that over the entire useful life. I think we normally do things around 30, 35 years now. Or were you saying that we would be recovering that cost for 60 years?
If I can jump in, the depreciation study will set the overall useful life of the facility. So for combustion turbines, combined cycles, generically around 30, 35 years. I don't have the depreciation rates in front of me and the survivor scales, but generally speaking, it would be whatever the useful life of the asset. So if nuclear has a planned asset life of 60 years, the depreciation rate oversimplified would be 1 divided by 60. As time advances, and let's say we get to year 30, and I'm not going to do math here on the fly, but we do second life extension for these potential new nuclear power plants, and they go to 80 years. When we do that depreciation study in that given year or for the rate case, we will account for that now extended life, no different than what we're doing now with our nuclear generation fleet.
And that's what's happened with the previous nuclear power plants, McGuire, and for example, near Charlotte, because it's been extended a couple. They're working on their second extension?
Yes. So for when the projects went to 60 years, that updated basically for the depreciation study, everyone got an additional 20 years. And now for projects that are seeking the second license extension, once those are approved, they will then also be updated for an additional 20 years. And so we just, for an depreciation schedule, we just add an additional 20 years, divide the undepreciated capital cost by.
All right. Thank you.
Thank you, Commissioner Kim Wright. Thank you, folks, for your presentation. I'm glad you guys are up to speed on this a lot. Can you tell me, if you recall, Dominion said that they generally look at one customer at a time. What is Duke's process? Is it build a generation and we'll, I don't mean to make a nonchalant statement, but flippant statement, but does that mean that we build a generation and as the customers come, they put them on the system? Or do they look at it at one customer at a time, or do you know?
I do know, and I'm gonna look over to both Dominion and Duke, that we have had these conversations and they usually have been very confidential in nature.
I'm not clear what the question is, sorry.
How much runway do I have here?
I wasn't clear on the question.
Yeah, I think if you're speaking generally to your understanding of the study process for large load customers.
And whether or not they're viewed as one-off or they're viewed as in multiples?
I think I don't have any concerns with that discussion.
Okay. So it's my general understanding is they're at least working through the transition. And again, I hope I got this right. They are looking at aggregate of projects.
Okay.
And looking at these. And so my understanding, when we're projecting out in time, this isn't Duke or Dominion specific, I'm gonna keep very generic so I don't go into too much confidentiality, is that they are looking at when can we have excess capacity on our system in order meeting the reserve margin, et cetera. And they have X amount of capacity. We have headroom on the system under this time period. And this headroom could be from transmission upgrades that we can import power from the market. This capacity could be when we're bringing on new life assets. This headroom could be from the flexibility that we talked in potentially delaying or accelerating potential coal plant reliability, coal plants. So when they look at the overall headroom, it says, well, we can bring in this load, and let's say we do it in a time sequence. First comes in, first goes out. We're not jumping out of order and cherry picking potential projects. This aggregate is 1 gigawatt. Here's the headroom that we can have, and then we'll say, this is how much you can have as we grow into that period. We're reaching saturation points of saying, we are, in my words, limited on how much more we can expand because either one, we don't have new generation coming online to maintain our system reliability and reserve margins, or two, we can't import any more power because we don't have any more transmission projects in the pipeline.
Okay. I just, I don't know, you want to speak to it, Jack, but I mean, you've got the largest data center population in Virginia right next door. You've got Dominion there. They're doing one customer at a time versus the aggregate approach. I mean, I'm sure that the two utilities talk. I don't think they give up any kind of competitive edge or whatever better to accommodate this. I'm just asking that question. Some states I've reviewed in this docket that have a 20-year contract. Is there one that is preferable to public staff? 15 versus 20?
Preferable, no. I think this gets into the tiered approach or potential risks that we're associated.
Okay.
There could be ways that we create, help me out here, Mr. Fahey. There could be ways that we could create a clear, transparent structure that says, look, if you want to come in for 10 years, guess what? You're going to have a higher demand exit penalty because you're placing more risks on the back end compared to front end. But hey, you know what? You want to sign a 60-year contract? Maybe they shouldn't have such a potential harsh demand penalty because it is over a longer period.
Along that same basic idea, there's the demand charge and also the scale of the customer. What may be true for a 10, 15, 50 megawatt customer is not necessarily going to be true for a 300 or 500 or 1 gigawatt size customer. And the system risks in general and the way that those customers are going to respond and what those individual customers are looking for to fit their business models are going to be different.
Okay, so what I'm hearing from both of y'all's response is each customer is different. Why not take one customer at a time versus the aggregate approach? I'm just pointing that out. I thought it was interesting to hear that. And then the last question I have is, we've heard a lot about co-location or self-supply or whatever. If SMRs come out at 300 and 500 megawatts, provided there could be changes in the law or restrictions, could you see behind the meter service ramping up there? It would seem to me that, you know, if they could provide it and hook onto the system, I know you said Duke would have to provide it if they went down because they're obligated to do that. I don't know how you plan for that. It seems to me if they chose to go independent with their own electrical generation, that if it goes down, they're on their own. But do you see SMRs being able to provide power to specific customers on a 150, 200 watt data center with a 300 watt? Seems to be the smaller SMRs that are being built or planned to be built by 2030.
It's theoretically possible. I mean, the ownership structure needs to be taken into consideration. The tolling agreements need to be taken into consideration. Again, if they're connecting to Duke's transmission system, that needs to be studied and evaluated. A very complex question. I do not have an immediate answer for, other than lots of items would need to be evaluated.
If that were to come about, though, that would accentuate the stranded asset problem, you know, that you have alluded to in your presentation. It seems to me that that would be a problem because Duke would have, as you term, more headroom if, you know, that system came along. I don't know. I'm just asking you a question about that, but that's fine. I understand you don't have an answer on today because they're not even operating yet. Thank you, Commissioner Kimwright. That's all the questions I have.
And Commissioner McKissick has some questions.
And I think you guys have done a great job in identifying the nature, the scope of the problems and the issues dealing with large load growth, how nuanced it is, the complexity of it. But if you were here today recommending to us as the commission, what would be the components to having a large load growth tariff? The things that you would think would be essential attributes to look out for ratepayers, to also not employ any type of policies or that might deter economic development. I mean, what would you think would be ideally what we should have done?
So let me jump in first, and I welcome my colleagues to bring in their respective insights. So two primary elements that I think are relevant is looking at a tiered approach. The tiered approach can identify the different risks. The liquidated damages need to be for the future system of which they're coming online and operating under, and not the system as it stands today, which has a lower overall cost to serve. Dr. Weaver.
Might be stealing Mr. Fahey's point here, but one of the things that we've recommended today and that doesn't currently exist in Duke's provisions is the advance notice requirement.
Right.
And we feel that is very important for providing transparency and clarity to everyone involved, but also helping with mitigating issues with resource planning and understanding what's happening in the future, because these companies will know, you know, a few years out if they're planning to reduce their load or planning to leave the system. And so that open communication is really important.
And I would add to that, in terms of at least a number of basic provisions are similar to what Duke said in its reply comments, where things that it already has as sort of their standards to be included into something like a tariff, in addition to other methods and other improvements that can be made on top of that.
And it's I mean, if Duke entered into that memorandum of understanding, year and a half ago, dealing with some of these large, low growth users. And I know there's been some back and forth about what, say, a large local tariff might look like. I mean, at this point in time, do you see there being some consensus of opinion about what the components are, say, that you have just identified, or other components that have been kind of out there being discussed that are providing perhaps some clarity or insight as to what might be forthcoming? I know there's been discussion about the correct timing being in a rate case. So, I mean, I want you to stay at a level that it's not problematic in terms of responding to my inquiry, but just trying to see where we might be thinking about moving to get something in place that will be meaningful, that will be significant, that will protect ratepayers, and that Duke might feel is reasonable based upon where things stand today.
That's a difficult one. So again, there's nothing, from my opinion, there's nothing materially wrong with the process in place now with the ESA. Just be really transparent.
Okay.
That we are looking for further process improvements, and we believe now is the time is right to do so in a proactive measure, get those emphasis on additional safeguards to ratepayers. Some of these things will require more communications with the company because we are not negotiating with the entity.
Right.
They have insight on what they will and will not do. But as the consumer advocate, we also have to be cognizant of there's a give and take between the utility interest, respectfully, and the customer interest. And we're trying to make sure that we have those additional protections in place.
And I guess the last inquiry is this: are there any lessons learned from Dominion's experience?
I would say yes, there are lots of lessons learned. I think Duke has incorporated those, and I'll turn the floor over here to Mr. Fahey to give more direct examples. But I think even today, they mentioned on September 1st, they had another revision.
Yes.
To be clear, I would expect more revisions as we continue to learn. Mr. Fahey.
I would expand on that, in that the ESAs, sort of as we're seeing now, they were established in early 2024. We already had this revision about 6 weeks ago. I know Dominion has gone through multiple revisions. If you read through the publicly released versions of the ESA, you can see how things were added to address specific concerns. And I expect more additions in the future to address concerns as they arise. So allowing that flexibility in an ESA to adapt to new concerns depending on what individual customers try and do, whether they're cross-shopping across different regions, or they try to change their mind at the last minute, or variations. The ability to change that ESA to put in protections against that sort of thing is important.
Thank you. I mean, I think that helps in terms of understanding where the landscape lies, and we have a lot to think about moving forward.
So I'd like to thank. So this comes to the end of the two-day technical conference. I want to thank public staff, Duke and Dominion, for their excellent and informative comments, and then their excellent oral presentations. They have been very helpful to the commission, and also the intervening parties presented excellent and informative comments and oral presentations as well. So with that, we will go off the record, and again, thanks to everyone.